How do you build a production-ready AI app using pgvector? There are lots of tutorials out there on vector databases, generating embeddings, even retrieval augmented generation. But how do you put these things together into a production application? How do you know what's good practice or bad practice, and how do you put it together quickly? We still need authentication, REST API, quite possibly file storage. What if you want to build a chat interface? How do you do that easily? What if you want to stream a response back from OpenAI? And then even with embeddings themselves, how do you split up a document before you generate embeddings on them? How do you choose the best embedding model? How do you store those embeddings in the database? How do you create indexes on those embeddings? What's best practices for calculating similarity between those embeddings? So in this video, we'll address all of those pieces. We'll build an end-to-end production-ready application using Supabase, the open source Firebase alternative. We'll follow modern best practices all the way across the board so that you can feel confident deploying your application to production in the wild. Specifically today, we're going to build a ChatGPT with your own files application where you can upload your own personal files straight into this app that you'll build and chat directly with them. Let's get into it. Okay, the way this workshop's going to work today is we're going to work out of this GitHub repo called Supabase community/ChatGPT your files. I have added this repository to the link in this video's description, so feel free to just click on that rather than manually typing that out. If you do plan on following along today, I would highly recommend loading up this README, as nearly every single instruction we'll go through today will be documented in here. And specifically the way this is going to work is if you do want to follow along, just go ahead and clone this repo, and then we do have Git checkpoints for kind of each milestone of this project, right? So in total, we have 4 steps, optionally a 5th step if you want to get some better TypeScript types. We'll talk about that at the end. And for each step, we simply have a Git tag for that step, so you can just go ahead and check out that step. We're going to start on step 1 today. But before we do anything else, let me show you what we're actually going to build today. So we have this app. I've already logged in to my account, and what you can do is 2 things. Number 1, you can upload files into the application. In this case, we're going to upload some markdown files. And then number 2, we can actually chat with those files. So using GPT under the hood, we'll actually be using a technique called RAG, Retrieval Augmented Generation. If you don't know this, don't worry, we'll talk about this in a second. We'll use this technique with OpenAI's GPT model to actually have a conversation with your files itself. So potentially you could upload files that GPT was never ever trained on. They could be personal files or company files. And with this app that we're going to build today, we can actually just have a full conversation with those files. So from here, we can upload. To speed things along, I've already uploaded 3 files. In this case, 3 files on the Roman Empire. When was the last time you thought about the Roman Empire? Once the files are uploaded, we can head on over to chat and ask it literally any question we want. So let's say, for example, we were wondering, what was the most common food they ate? There we go. The most common food consumed by the Romans was cereals and legumes such as bread and pottage. And to prove that this actually came from the documents, we can head on over to our files. I believe this was in Roman Empire 2. And if we just search for legumes, there we go. Romans consumed at least 70% of their daily calories in the form of cereals and legumes. So our chat application is indeed pulling this information from our files. Now, there's a whole technique behind this. Technique is called Retrieval Augmented Generation, or RAG. And if you haven't heard of this, just hold tight. We're going to fully dive into this in this video. All right, without further ado, let's get into it. So some prereqs for today. You will need a Unix-based operating system. So basically, if you're on Windows, just use WSL2. If you don't know what that is, just Google it. There's tons of information on WSL2. We'll be using Docker for local development. Now, this is actually optional. Within this step-by-step guide, we actually have 2 approaches throughout it. So we can use the local stack. So for those of you who are interested in like the open source side and you want to run this yourself, you want your database to run on your own local computer, you want the embeddings to run locally and everything, you can go ahead and follow this local guide, which will use Docker under the hood. Or if you don't have Docker available and you're just interested in using a cloud database, that is perfectly great. With Supabase, you do get 2 databases for free. So might as well take advantage of those. Because I think a lot of you are interested in the local development flow, I'm going to go ahead and run through the local Docker approach throughout this workshop. But again, anytime there's a situation where you need to choose, just come back to these docs and there'll be a cloud option, which you can follow those instructions as well. For those who have never used Supabase, all Supabase is just Postgres under the hood. So within Docker, what you're getting is, well, Postgres, of course, with a bunch of extensions added. Notably for our workshop today, you get the pgvector extension built right in. If you didn't use Supabase, you would have to basically go through the work of creating your own Docker image on top of the Postgres image. And then in addition to the Postgres image, Supabase actually has a bunch of extra services that make development really quick. So for example, auto-generated REST API, integrated storage API, all this is kind of just built into the stack. You don't have to worry about it. And personally, I love that it's all open source, so you can literally just run the entire stack locally. Quite amazing. So go ahead and clone this repo if you haven't already, assuming you want to follow along. If you don't want to follow along, you just want to watch this video, like that is totally cool too. Feel free. Hopefully you learned something just by watching me as well. So I've already cloned the repository here. If after pulling in the repo, it says main, then go ahead and just copy this command and we're going to check out step 1. Step 1 is basically a blank slate. We do a couple things. Under the hood, the way I created this repository is very simple. All I did was run npx create next app at latest with the template with Supabase. So there is a Supabase template available for the create next app, and all it does is basically scaffold out your entire next application like you normally would with create next app, but with a bunch of Supabase functionality built in. So I've already done that. That's what this repo is at step 1. I did add a couple extra things just because there's a couple of extras we need, like some useful hooks and our sample files, of course. But for the most part, this is all just a vanilla create next app. So based on that, clearly we're using Next.js as our front end for this project. Really, you could choose any framework you want. Next.js makes development in React quite simple, so that's what we're going to use today. Perfect. So we're at step 1. Next on the list, we're going to just do a quick npm install just to make sure we have all our dependencies up to date. That was very quick for me because clearly I already had them installed. For you, it might take just a little bit longer, but hopefully not too long. Okay, following the local steps, again, if you would prefer cloud, follow these cloud steps instead. But to do the local steps using Docker, of course, make sure you have Docker installed first. And once you have that, all you need to run is npx supabase start. So the Supabase command is the CLI that Supabase offers. Basically, the CLI comes with a bunch of commands you can use to run the entire stack locally. You can run migrations. You can push your migrations to your cloud instance. You can sync them together. Kind of everything you'd expect from a Supabase CLI. And under the hood, the CLI is spinning up some Docker images for us and setting up our database as well. Perfect. So when that's done, you basically get this list of services. These are the different services that I was mentioning. They're all included with the Supabase stack. Again, it's all open source, so you can feel free to look at the source code if you're interested. But importantly, we care about a couple of things here. So number 1, our database, it's being hosted on localhost 54322. We have an API URL. This is our API gateway we'll use to connect to the REST API, for example. There's actually a GraphQL API. So if you prefer GraphQL, you can actually dive into that and use that as well. And then one really cool thing here is you actually get the studio URL as well. So using this, you can actually pull up a full-on studio. It's completely local. And you can go to the table editor, for example, and check out your tables. We have a dummy to-dos table that we're actually going to remove in the next step. But basically, the studio gives you full access. Think of it like a SQL studio, right? We have a full SQL editor here as well. So it's pretty great. But let's stay focused. Next step here is to set up some environment variables. Of course, from our Next.js front end, we're going to need the ability to connect to our Supabase backend. Thankfully, Supabase has a Next.js integration library available that makes this very seamless. So all we got to do is use this command. We'll copy it, come back here, paste. And all that did is it created this .m.local file with our Supabase URL set up automatically, which for the local scenario is pointing to our localhost, and as well as an anonymous key that we use to basically authenticate anonymous users. The anonymous key in Supabase is safe to be shared publicly. This is something used directly by the client. Okay, now that setup is complete, we can get right into the build. So first things first, we're going to create a migration file. So go ahead and copy this command. We'll paste it. Now, if you're new to migrations and you're saying, Greg, what is a migration? Well, let me explain. A migration is basically a SQL file that tells our database how to build the entire database. So things like table schemas, functions, everything that we put inside of our database itself, we're going to create through migrations. And if you've never used migrations before, the beauty of migrations is you can have a whole team of developers and everybody can clone this repo and start the project, and under the hood, it will just run all the migrations for you. And basically everyone will have the exact same database schema on their own local computers. and let's say in the future somebody needs to add more tables or modify tables, then all that's needed is to add one more migration file, and next time they pull the latest changes from the repo, it'll just apply that new migration file. So migrations are a great way to basically keep track of database changes in a sane way. So what we did is we said npx Supabase migrations new files. What this command does is it creates a new migration file called, in this case, files. Why are we calling it files? Well, this migration is going to basically manage the file upload feature that we're about to build. If you recall me saying, object storage in Supabase is actually completely managed within SQL itself, which is quite incredible. Actually quite useful, because what that means is we're able to apply like row level security and all your like authorization logic directly within the database, and it will translate automatically to the object storage. Now, I should mention real quick, the raw files themselves aren't actually getting stored in the database, right? Those are stored in a separate object storage under the hood. Just the relationships and all the policies on those objects are stored in the database. So how do you set that up? Let me explain. First things first, we're going to create a new schema. This isn't a Supabase thing, of course. Right now we're doing SQL, so this is all within Postgres itself. So if you're not familiar with schemas, you can have multiple schemas. Think of them like namespaces. By default, you get a public schema, which actually Supabase will make available publicly to your front end through the REST API. Of course, we can still add authorization logic around that. But if you had any kind of database tables that you don't want to even show up in the REST API at all in any circumstance, you would create another schema. In this case, we're going to call ours private, which would never be exposed. Okay, next we're going to go ahead and create our storage bucket. Copy this command in. So insert into storage.buckets. Storage is yet another schema, and buckets is a table. So this table is actually built in to the Supabase Postgres image. This all comes kind of for free. Of course, it's empty by default, so we're inserting a bucket. So again, if you're familiar with S3 buckets, you would create a bucket to store all your files. That's exactly what this is. We're going to create a bucket literally called files in this case. The ID and name will make them both files. Okay, next we're going to create some RLS policies. Let's copy and paste those right in there. Let's talk about this one for a second. So RLS, what is RLS? RLS stands for row level security. I think row level security is a lesser known feature of Postgres, but in my opinion, should probably be way more known. It's such a powerful feature that once you start using it and you understand it, it's like, okay, this is kind of a no-brainer why you'd want to set up your authorization logic this way. So essentially what row level security does is it applies exactly that, your authorization logic directly on the table itself. And so why is that useful? Traditionally, I think many of us, if you have experience building a full stack application on the back end, you would build in your authorization and authentication logic directly within your like API layer. So for example, if you had a Node.js backend and you're using something like, let's say, Express, or maybe something more advanced like Nest.js, you would build in all your authorization logic there. And like that's totally reasonable. Honestly, if you're already building a whole Nest.js backend, then that's quite likely something you would consider doing. However, what if we took that authorization logic and actually moved it all the way down into the database itself? So instead of in our API layer checking it to see if someone has access to certain files or restricting, say, a table to rows only that they own, we can go ahead and actually set that logic directly within the database itself. This is called RLS, and it's done through this create policy statement. So essentially say create policy, the name of your policy. In this case, we're going to say authenticated users can upload files, meaning only once a user is logged into the platform are they able to upload files. Otherwise, no dice. And then actually on top of that, we're going to make sure that they can only upload files to the files bucket, right? So in case we add more buckets in the future, this policy forces them to only do that on files, as well as it ensures that the owner is them. Now this auth.uid, this is a special function built into Supabase Postgres that basically captures the current user logging in. How does it do that? Well, since we're using this auto-generated REST API under the hood, this is actually a service called Postgres, this one. Pretty cute little icon there for the REST. Yeah, this service will essentially monitor your database in real time. So it checks which tables exist in your public schema, and it will go ahead and generate a REST API automatically on the fly. So inserts, updates, deletes, selects your full CRUD available automatically without doing a thing. Of course, since this is building your API for you, how do you manage security? How do you manage authorization? That's exactly where RLS policies come in. So if you're using something like Postgres, in this case through Supabase, then RLS is basically a requirement to make sure that you actually lock that down properly. But I really do think that more of us should be considering RLS even for any other application, to be honest, because think about it. If you create an API route that does, you wrote the proper logic to restrict access to a certain table within that API route, that's great and it's working. But what about next time you build a new endpoint in the future? You're gonna have to continuously add that logic over and over again, or some sort of abstraction. There's more places to get it wrong. Whereas when you apply the RLS logic literally at the lowest possible level directly onto the table itself within the database, there's no question, like there's no accidental opening up API endpoints to give users access to tables they shouldn't by accident. The security is applied within the database itself. So it doesn't matter if you're doing joins or creating special functions. At the end of the day, the row level security remains in place. So just some food for thought. Of course, RLS can be applied to more than just inserts. We can apply it to selects, updates, and deletes, all 4 CRUD operations. In this case, users can view their own files. So basically we're saying create a policy on the select where as long as they're selecting from the files bucket and the owners themselves, then they're allowed to do that. By the way, owner, this is a column, right? If you're wondering where does owner come from, or bucket ID, these are just columns. These are columns within the buckets table. If you're curious what these columns are, then we can pull back up our handy dandy studio. What was that again? If we say npx supabase status, that will pull these back up again. If you ever lose them, status is the command. And then we have our studio URL. So coming back here again, we can head on over to the table editor. By default, we're in the public schema, right? These are the schemas I was talking about. Head on down to storage. And then here we go. Here's our buckets, which we haven't created quite yet because we haven't applied the migration, but that will live there eventually. And then we have objects. So objects are there'll be an object for every single file that gets inserted into the bucket. So think of an object as a file. It's one-to-one. So from here, we can actually head on over to definition and check this out. We can see all the columns within this storage.objects table. So particularly we have bucket ID, right? This maps to bucket ID here. So ensuring that they can only pull files from the files bucket. And then we also have owner here, which is the actual user that this belongs to. And that maps one-to-one to this column here. Now, if you're wondering where are users stored, let me tell you, we have another schema for that called auth. Again, all these are kind of built-in schemas for Supabase. Come down over into users, and this table will store all the users that we insert into Supabase. So assuming you're using Supabase for authentication, which I would highly recommend because everything is just fully integrated, all your users will show up here. And it's literally just another table. So you can reference these user IDs from all your other tables. In this case, specifically, you can reference it from our storage objects. So these are all empty right now. We'll fill these out shortly. But for now, let's finish our migration. We'll close some of these tabs, come back to our docs. Okay, so next on the list, we're going to go ahead and modify our front end. So let's get into our Next.js project. Our Next.js project is using Next 13. So this means we're going to be using the app router. Don't worry if you've never used app router before, or even Next.js in general. Kind of everything is set up for you already. All you got to do is follow these instructions to kind of modify it. But I did try to design this in a way that there isn't too much magic happening. Most of the things that are already set up for you are just like styling and UX and UI stuff. Just because this video could turn into a 10-hour video if we had to do all that ourselves. So thankfully that's all done for you. What we'll be doing here is just adding in the appropriate logic. Okay, so head on over to our app files page. So here we have app files page. This is our front end code. Here's our files page. This will map one-to-one to our files page. So let's quickly spin up our front end so that we can actually see it. So to do that, we'll do npm run dev. This command comes from package.json here. Dev just runs the Next.js dev command, which just spins up a local front end project. As you can see, we're listening on port 3000. We'll open that guy up and we're greeted with this chat with your files using Supabase screen. Now, I guess probably now's a good time to show you the authentication piece. So let's click login. This will bring us to a /login page. This is just a really super simple form, login form right here. You can check it out here. Feel free to go through this on your own time, but honestly, it's very, very straightforward. All the auth logic is actually included in the template for you. So again, if you run that create next app -e with Supabase, it will come with all this for you. But just super high level, it comes with all the routes you would need to do proper login and sign up, right? So we have sign in, sign out, sign up, which is registration, and then actually a callback that the authentication route will use to basically redirect once you're signed in. And then within all of these, of course, we're just using our Supabase next helper. So there's actually not too much logic that needs to happen here. to actually interface with the database and create the users. If you're interested in all those details, like definitely feel free to dive into this on your own time. If you're not interested, that's totally cool. You don't have to do a thing. At this point, we can just log in by creating a new user. So I'll create a user called Greg at example.com, create a password, and then I'll click sign up. Now I'm in. Now, of course, in a production application, you'd probably want the user to confirm their email address before it takes them directly in. I mean, not necessarily, but that's a very common flow. So let's say you did want that. That's all configurable within Supabase. So locally here, I should mention there's under the Supabase folder. By the way, Supabase folder, this contains like all the Supabase specific stuff, right? The rest of this is mostly Next.js front end stuff. So all Supabase is kind of under this folder. And then within this folder, we have things like edge functions, which we'll get into, migrations, which we've already started. And then some other things, we have a config.toml. This is basically configuring our entire stack. So say you were interested in emails actually being like confirmed by email before you're allowed in, you would just come down here into, I believe it's auth.email. Here we go. So enable confirmations false. It's false by default for local development, just because usually you don't want to do that. It's kind of a pain, but you could set that to true, in which case it will actually send the email. Now for local, it will actually go through a different service. Let me pull that back up again. npx Supabase status. We have this service called inbucket. What inbucket does is it basically just, it's like a catch-all. So when it sends an email, and instead of actually sending the email to a real email address, it sends it to like a fake inbox that lives here. It's just a nice way to capture emails in local development without actually having to send it off to a real email address. So that's available for you. I think a lot of people actually miss this. So I did want to mention that real quick in case you were interested in experimenting with emails within Supabase. Within local, by default, it will show up in this in bucket. Okay, let's close that. At risk of going too far down the rabbit hole, let's get back and focus on our job. So we've logged in, we have our files page. Let's go ahead and click on that. And this is where you can upload files. So this page right here, /files, this maps one-to-one to our, this is our login page, close that. Here we go, our files page, app, files, page.tsx will map to this page. So coming on back to our README, we're gonna go ahead and copy and paste this. So this basically will instantiate a Supabase client using this command. We'll insert this at the top of our component. So right up here, we can insert that. Of course, it's gonna be not imported by default. There's a actually really handy keyboard shortcut. If you're on Mac, Command-Shift-I. I think it's Control-Shift-I on Windows. If you don't have that, you can also, I believe, hit Command or Control dot, and then you can import them one by one. But I just love, this is like muscle memory for me now, just because it's like, you just use it all the time to add in the missing imports. Okay, we have our client. So this will basically instantiate a Supabase client. Do note that with this command, it's actually creating a singleton under the hood. So if you're a React guru and you might look at this and be like, well, this is terrible because what it looks like it's going to create a brand new Supabase instance every re-render. Thankfully, no, it is using a singleton pattern under the hood. So basically the Supabase client will be global through our entire app. If you do prefer to manage the Supabase state yourself, there is an option here. I believe it's is singleton. By default, that's true, but you can say is singleton false. And now it literally will create it every render. So from here, you would probably wrap it into your own context or something like that if you really want to manage it yourself. But we don't need to do that. By default, the singleton pattern works great. We only have one Supabase instance, so this is awesome. Next, let's actually handle the upload itself. So we'll copy this snippet. It's going to live in the inputs on change handler. So we'll come down here. We have an input box right here. This input maps to this kind of input button here. The reason why it shows up like this, by the way, is because we set the type file. Inputs in HTML can have many different types. Here we go. Buttons, checkbox, color, date, you name it. There's actually way more than I thought. So when you set it to file, by default, it will look like that. We'll give it a name as well. And we have the onChange handler. So this onChange handler essentially will get triggered when someone selects a file. So I've already helped you out. Just grab the file from the e.target, check to make sure it exists, and then let's go ahead and replace this comment with the snippet from the README. All right, let's go over this. What's actually happening? So we have our Supabase client. From here, you can do lots of things. If you've ever used it before, you might be familiar with .from. When you say .from, you can actually just reference a table directly. So let's say we had a table called to-dos. Then you could say supabase.from.to-dos, and you could say .insert or .select, and then you can select. So it's kind of, think of it like a query builder under the hood, where you can reference these tables. Again, this is actually going through a REST API under the hood. Even though it feels like a query builder, it is going through that API. So all your authentication logic and security is in place when you're using this API. But for this specific use case, we're not going to be actually connecting to a table directly. We'll be using the storage subcommand. So similar to the root Subabase command, storage also has a .from, but in this case, it's referencing a bucket instead of a table. And then from there, we have some special commands that only relate to storage. So in this case, we're going to call upload. First parameter is the path name where this file could get uploaded, and second parameter is the file itself. So of course, this is of type file. This is a built-in type as part of the web standard. Perfect. So once we select a file, this onChange handler will get triggered, and we'll go ahead and upload the file to this path. Now you might be wondering, what's with this UUID thing? What's going on there? It's important to note that just like any object storage, so think again like S3 if you're familiar, every file path that you upload needs to be unique, right? So if say we were to scrap this part and only upload the name of the file, which this would literally be whatever name of the file was on disk, that's great for the first time, but what if the second time you upload a file with the same name, or somebody else on some other account uploads a file with the same name? There'll be a conflict. So we need to add some extra logic to make sure that the actual path is unique. So in this case, we're just using the browser's crypto API. There's a command called random UUID, which funny enough, I actually didn't know this existed till recently. I've always used the UUID npm module until I realized that this is built right into the browser now. So how handy. Clearly I'm behind the times. Anyways, you might be thinking, well, why do we even need the file name at all? Why can't we just save it as a random UUID? Well, you certainly can. That's totally reasonable. The only problem with this is you do lose some information. Specifically, you lose the name of the file. So say in the future when we're showing the files here, like the files that they had uploaded, it'd be nice to show like the original file name that they had uploaded, right? Instead of just some random UUID. So with this approach, we actually lose that file name. So what I propose here is we'll just say slash. So as if this was put into a folder under the hood with object storage. Slashes really don't mean anything. It's just a file name, but a lot of them treat slashes like as if they're directories, just from a UI perspective. But think of it basically as the whole thing as the file name. So basically we're saying create a UUID and then store the name of the file after that within a quote unquote subfolder and pass it in. So let's try it out. Let's see what happens. So supposedly that uploaded. Let's actually look at it again through our dev tools here. So we'll refresh the page and let's do it again, clear this. Okay, so never mind, we actually got an error. What's the error here? Bucket not found, 404. So for whatever reason, it thinks that this files bucket doesn't exist. And well, of course it doesn't exist because we haven't run our migration yet. So the problem is this command was never run. Once we actually insert the bucket into the files table, it will literally create that bucket for us. But until then, nothing exists yet. And by the way, in the studio, you can actually come down to storage, and this will actually show your buckets as well. So this kind of also proves, oh yeah, we haven't created any buckets yet. You do have the option to create buckets through the GUI here. I would recommend in general doing it through migrations, just for the reasons we talked about earlier when you're working on a team. For those who like to get under the hood, also there's that storage bucket here, right? So recall we have objects, this maps to a file, and buckets here. This is also empty. So essentially we need to go ahead and run this migration. Real quick before we run that migration, there's one more piece I want to handle, and that is we can actually be a bit better on our RLS policy, right? Right now when we insert into our files bucket, all we do is we check the owner and we check the bucket ID, which is great, but I think there's more we can do here. We come back to our README under improve upload RLS policy. Let's go ahead and copy this function over. We'll just paste it right above our first policy. So this function is called UUID or null. So essentially what this function does is it checks to see if the value you pass to it is a UUID. If it is, it will return it. If it's not, it'll just return null. So basically it allows us to identify whether something's a UUID or not. Next, we're going to go ahead and replace our insert RLS policy. We'll copy that, select this, paste. So we're just going to replace it with this new one. And the addition that we're doing now is this part here. So we're checking to see if essentially the path tokens, so when you upload a file into object storage, there's actually a column called path token. This is actually an array column. And there'll be an array of all the different paths. So back to here, I told you we delimit by a slash. So actually this first piece here will be the first path token. And then after the slash will be the second path token. If we had more slashes, more directories, quote unquote, then those will be additional path tokens within that array. So if I say path token 1, that's actually grabbing the first directory in that path. And by the way, this tripped me up. It is in fact 1, not 0. For one reason or another, Postgres arrays actually are 1 based and not 0 based. So don't let that trip you up. 1 is literally referring to the first segment. So big picture, what we're doing here is we're basically making sure that this first directory is a UUID. because we're checking to make sure it's not null. Why do we want to do this? Well, it's important to remember the concept of never trust the client, right? Even though in our client code, we tell it to be a UUID followed by the actual file name, nothing actually stops people from being malicious and changing that, right? Never trust the client. So if there's a malicious user, they could freely upload a file, even if they were logged in, right? They would have to be logged in actually because we have these first two policies here in place. But after that, nothing stops them from uploading it to whatever path they want, really, which could conflict in the future or whatever. It's just bad practice, right? So let's actually force this first path to be a UUID so that malicious users can't do anything bad. We'll save that. Now that we have that in place, we can go ahead and run our first migration. This is exciting. We'll copy this command, open up a terminal. If you haven't already, by the way, you can just click plus here. If you're in VS Code, open a new terminal. We'll run Supabase migrations or migration up. And just like that, we've actually applied our files migration. We can confirm that this migration has been applied by doing a couple things. First, we can check if the files bucket exists in Studio. There we go. There's a row for files. We can actually also go down to storage. Now we can see there's a file bucket. Perfect. And last but not least, for those who like to get under the hood like me, there's actually even a Supabase migration schema and table that actually will track these migrations as they've run, right? This is important because if I ran this command again, it knows I'm already up to date because it checks this table. I just noticed we actually also have a to-dos table. This is actually coming from the original template that we're actually going to need to remove. So we might have an issue where we need to reset our database shortly. Don't worry, I'll walk you through that. That's probably going to come up here very shortly. But now that we have that in place, we can come back to our front end. We'll refresh, we'll choose a file, upload, and great. We actually got a 200 instead of a 400, meaning that it supposedly uploaded properly. The response looks like this, looks promising. We can come back to our studio, come down to storage, files, and boom, there's our very first file. And well, I guess that's the folder and then the file name, just as we planned. Once again, this is all integrated right into the database. We can come down to the storage schema and objects, and boom, there is our file. Now, of course, I should mention if at this point you aren't following the local stack and you are using the cloud, go ahead and run npx supabase db push, and that's the equivalent command to take that migration and push it up to your cloud instance. All right, well, congratulations. Step 1 is done. We're going to move on to step 2, which is our documents and setting up some tables to manage our documents for retrieval augmented generation. So if you are following along and you're not caught up, feel free to just run these two commands. So we're going to run git stash push, my work on step 1. That basically stashes everything we've done. And then we're going to go ahead and check out step 2. Now, this was the part I was worried about. I realized in step 2, I had removed the to-dos migration. This is usually taboo. You never remove migrations later on in commits. Really, I should have removed that at the very beginning because we don't ever use that to-dos. It was just part of the template. But too late now to resolve this. If you're on the local stack, you can just go ahead and run npx supabase db reset. This is actually quite a handy command. What this does is essentially takes your database and wipes it clean completely. So if you're ever kind of in a weird state and you're just like, what is going on? I don't know exactly what I've added or not added, and you just need like a clean slate, this is the perfect command. And as you can see, now that it's started back up again, it applied our migration here. So in this case, the only migration that we should have had all along, and then actually applied some seeds, which we'll talk about shortly. Close these guys. Okay, so let's take a quick look at what we're about to build. If you've ever done retrieval augmented generation before, you probably know that best practice is to take whatever document you're working with and splitting it into smaller chunks, or in this case, we're going to call them sections. Why do we do that? Well, for a couple of reasons. Number one, when we're performing retrieval augmented generation, recall what we're doing is we're searching our knowledge base. So in this case, searching through some of our tables for the most relevant documents to the user's query, right? So back here under chat, the user's asking, oh, of course I need to log back in. Let's close DevTools. The reason why I need to log back in is because I did that DB reset, right? All of my information's reset, including our credentials. Thankfully, it's very easy to sign back in. So as I was saying, coming to chat here, we're talking about retrieval augmented generation. So say the user asks, what is the most common type of food they ate? Right? So first of all, let's assume that I've actually uploaded those files. I know it got reset, but let's just pretend that those are still there for the Roman Empire. If I just send this directly to ChatGPT, let's say it didn't have all the details that we had in these files. essentially we want to use retrieval augmented generation here. We want to take this query, we'll actually generate an embedding on this itself, right? Think of it like a plot on a graph, and we want to find all of our documents that are similar to this, right? So if we're generating embeddings on our entire documents themselves, there's a couple of challenges with that, right? Number one, documents could be really big. And if it's big enough, it will actually never fit within the context window of an embedding model. So you try to generate an embedding on the text, it will actually either truncate it. Most of the time, most models just truncate it, or some models might just throw an error. If you're wondering how many words or characters will fit in an embedding model, each embedding model is different. The reference I would recommend checking out is the MTEB leaderboard. This is a leaderboard designed by Hugging Face. And they've done a really awesome job here, basically coming up with data sets to test all these different embedding models against for different use cases. And this is the leaderboard. This is like the combined all-time leaderboard. Interestingly enough, if you come down here, OpenAI's is way down here in 15th place. There's a ton of open source models that actually perform better than that, at least today. Actually, one of the ones we'll be using today is GTE Small, which is now 14th place, but it is a very small model, which is why it's attractive for us today. Back to the context window, it's a sequence length column here that will tell you that. So most of these models have a context window of 512 tokens. Now, keep in mind, we're talking tokens here, not characters or words. If you're not familiar with tokens, every model tokenizes their text differently, but think of tokens as just a way for a model to translate your text into a meaningful representation that the model understands. In general, a token is usually like 4 English characters, but that's a very rough approximation. If you're using OpenAI, for example, they have a tokenizer that does a really good job of kind of explaining how this works. So if say I'm thinking about the Roman Empire. So you can see how this is working, right? A token isn't necessarily a word. As you can see, it split I and apostrophe M into 2 different tokens. In general, character sequences that it sees most often tend to turn into a token. So often that does translate to words, but not always. Sometimes a word will get split up. For example, if I add an S to empires, you can see it actually broke that into M empires. For whatever reason, it decided that was the optimal choice to split. So even though we have 36 characters here, it's actually only using 8 tokens. So keep that in mind. You might look at this 512 token sequence length and think that that's kind of small. But in general, we're going to be splitting up content anyways, and 512 usually is more than enough to fit the content we need. Plus allows us to use these higher performing embedding models. So reeling it back to documents, that is one reason why we wouldn't want to take the entire document and try to generate embedding on it. Another reason would be, even if we did use a massive context window like OpenAI has, 8096, you're working kind of at too large of a granularity, right? If you create one embedding for your entire document, like that Roman Empire document had like a ton of different topics that were completely unrelated. So if you try to create one embedding on that, I'm not convinced that embedding would be placed in a location that wouldn't necessarily capture the meaning once we ask it some queries later on, right? So better to split that into more semantic chunks that are more meaningful, right? So we have a heading. This part of the Roman Empire document is talking about the foods that they ate, right? This one's talking about where they lived and the building structure, etc. So it's better to chunk by semantic, more meaningful sections so that their embeddings are capturing just that granular piece, right? So because we're going to be splitting it into smaller sections, we're actually going to create 2 tables here. We're going to have one table to represent the document itself. And as you can see here, this is actually just going to be a direct relationship to that object ID on the storage table that we've already looked at. So this is a one-to-one relationship. We're actually going to also store who created that document. For our use case today, of course, for you, if you had like, say you wanted multiple people to work together on a document, or you had a Teams concept in your application, in that case, you wouldn't be storing created by directly here. You would be creating a join table to do relationships. If you're interested to learn more about that kind of stuff, let me know. We actually do have documentation on this on the Zubabase website. I believe it's under RAG with permissions. Feel free to check that out. Here we go, RAG with permissions. We have a section here on documents owned by multiple people. So feel free to check that out if you're interested in that kind of concept. But for now, for simplicity's sake, we're just going to have one owner per document. And then of course we have a one-to-many relationship between our documents and our document sections, where the document section represents kind of a small chunk within that document. And notice here, this is actually where we're going to be storing our embedding itself using this vector data type provided by the pgvector extension. And honestly, this right here is one thing I love about Postgres just in general is you get that full control, right? We're building an app. I imagine that's what most of us are trying to do. Lots of this really cool AI stuff is only meaningful if we can actually implement it, right? So with something like Postgres, you get full control of your entire schema, and then we can actually actually just use pgvector to go ahead and store our embedding as a first class data type directly within our existing application data structure, right? Not to mention when I query our embedding, it's going to be a lot quicker because it's all within the same database, right? Versus going through, say, like a separate dedicated vector database. And lastly, of course, I'm biased because this is a super-based video, but we have done benchmarks on pgvector as well against some of the big vector databases. In this case, we did a post on pgvector versus Pinecone and just did a cost and performance comparison and actually found that pgvector performed very, very well at the same compute levels. This is, of course, thanks to the latest update, which is HNSW. This is a new index type that has been added to pgvector. Since HNSW has been added, pgvector has actually just been like incredibly performant, complete game changer. So theory and explanations aside, let's actually go ahead and build this. We're going to go ahead and create a brand new migration for documents, copy that, we'll paste it. From here, we should expect to see a new migration file. There it is for documents. So next we're actually going to create some extensions. Let me explain this. We'll copy and paste that in. First, we're going to create an extension called pgnet. Pgnet is actually a very interesting extension, in my opinion. It's an extension that allows you to actually perform HTTP requests. So think GET request or POST request, literally from within Postgres. So recall earlier we created like this function. You can create these functions within Postgres and call them within Postgres as we did down here, right? So what pgnet does is actually gives you additional functions to call HTTP endpoints, which is quite awesome. And then of course, we also need to create the vector extension. This is in fact the pgvector extension. When you go to create it, you don't say pgvector, by the way, you just say vector. That's how it was kind of registered within Postgres. So don't let that trip you up. Vector is the one you're looking for. And once we do these, basically both of these extensions will be now available. Without that, they won't be. So if you're ever trying to use, say, the vector data type and you're getting an error saying, hey, I don't know what this vector data type is, quite likely you forgot to enable the extension first. Okay, next, let's go ahead and create a new table. This will be our documents table that we were just looking at here, right? This guy. Pretty standard if you're familiar with building SQL tables. We have an ID column. This is auto-generated and will be auto-incrementing. Also, it will be our primary key. We have a column for name. This is just going to keep track of the name of the document. Storage object ID. This is a foreign key reference to our storage objects table. Again, the beauty of integrating our storage directly into SQL means we can actually create proper foreign key references, which is awesome. That is a one-to-one relationship created by, once again, foreign key reference, but this time to the users table, defaulting to just the current user. And then also we have a created at time just so we can track when this document was actually added, defaulting to the current time. Moving on, we'll create a view, and I'll explain this in a second. Go ahead and copy and paste that in. This view we're calling documents with storage path. If you're not familiar with views are basically the exact same thing as a table, except all they are is like a query. So in this case, the contents of the view is a select query, but you would be able to call this view as if it was a table, and it would just do this under the hood for you. So the reason why we want to do this is because later on we'll find out that documents this table is great to have, but there's one piece that's handy to have with that, and that's the storage object path. So the actual storage object name coming from the storage objects table. On our front end, it's going to be really handy having this available. And since these are cross schema, it's a lot easier just to do the joins within a view than from the front end. That would be a lot more difficult. So we're going to create a view. Now, note this part here with security invoker true. This is very important. So in the future, if you're ever creating views, pretty much you're almost always going to want this enabled by default, at least, unless you have a good reason not to. What this means is when you create this view and somebody actually calls this view, Postgres needs to decide what the permission level is for the people using this, right? We have a bunch of RLS policies that we'll actually create in a second here for the documents table. So by default, if you don't have this command, then this is actually going to be a security definer, which means that the permissions of this view is actually the permissions of the role actually who created this view in the first place. So like think of it like an admin role. When we run this migration, you're basically an administrator when you create these views, and that is the role that it will use to actually call this view, which is usually bad practice because that role typically will have way more elevated permissions than the permissions you actually want to provide with this view, right? So when we say security invoker true, that means actually basically inherit the permissions of whoever invoked this view versus defined the view, right? So this will in fact inherit the same auth UID user all the way from the front end when it calls this, as long as we have this in place. So just FYI, keep that in mind when you're creating views. Next, we're going to create our document sections table. Once again, this one over here. Very similar to the documents table, but this time we're going to actually reference the document ID as the foreign key, right? That's the one-to-many relationship. The content itself, so what is the content of that document section? We need to store that so that we can actually perform that retrieval augmented generation. This content is what we'll use to inject into our GPT prompt later on. And then finally, last but not least, of course, we need our embedding. This is the name of the column, by the way. You can call this whatever you want. I think embedding is most appropriate. The data type is vector, and then the size is the number of dimensions, right? So we'll actually be using a model today. I think I pointed that out, GTE small, which is 384 dimensions. So that is going to be the size of our vector today. Worth noting, when it comes to dimension size, if you can, lower dimensions is typically better when you go to scale. At Supabase, we've actually seen lots of customers. Many customers use OpenAI's embeddings. So the embeddings from text embedding 82, which is 1,536 dimensions. Those embeddings are great, although, as I pointed out earlier on the MTEB leaderboard, there are, in fact, nowadays, there's actually many models that perform better, but this is actually one of the highest dimension models that exist today. And the consequence of that, unfortunately, means that they take up way more space in your database. Also means it takes way more space in memory. Takes a lot longer to create indexes on. Once you scale up to a large number of records, we're seeing lots of issues where people are actually hitting some scaling issues with this dimension size that they would have never actually hit if they chose a model with smaller dimensions. Of course, at a certain point, you're going to have to scale your database appropriately and increase the compute and memory and disk space. That's a necessity that will never go away. But I think you can get a lot farther when you're using models with lower dimensions. So that's what we'll use today. Okay, back to here. Let's go ahead and create an index on our document sections table. This is the HNSW index, the one that I was talking about. That's the game changer. In general, I do recommend creating an HNSW index as opposed to the older type, which was called IVF flat. I recommend it because, of course, performance is much better, but also you can create the index right away, right? In this case, when we run this migration, it will create the table and then immediately create the index, which means the index is going to get created on essentially an empty table. And for HNSW, that's perfectly fine. What HNSW will do under the hood is as you add new records, it will continuously think of it as like rebuild the index on the fly as you add new data. So your HNSW index will always be more or less optimal. Whereas if you were to use IVF flat is actually depends quite greatly on existing data in your table. So if you had no data in your table and you create this index, it's going to try to create these under the hood. It creates these like cell clusters as part of the indexing algorithm. And the cluster points that it chooses will be like extremely unoptimal because it has no idea where your data actually lives. So in general, if you're going to use IVF flat, pgvector recommends that you have sufficient data first that kind of represents the distribution of your data already before you create that so that those cell clusters are actually created in appropriate places. Otherwise, this index will perform very poorly, right, if you were to create this too early. So anyways, for both those reasons, we're going to use HNSW as our default index. Just to explain this real quick, we're creating it on the document sections table, right? That's referencing this exactly. This is the type of index, and then this is referencing the column. So since we called the column embedding, that's what we put here. And then finally, we choose the operator. In this case, we'll find out later on when we actually do the similarity search that we're going to be using an operator called inner product, also known as dot product. This is one of the more performant distance functions, and we'll go into this more later, but we can use this one because our embeddings will be normalized. So if you were to use a different distance measure like cosine distance, for example, you would need to adjust this accordingly to make sure you're creating the index on the right operator. If you're curious what the operators are, that is also all documented. If you go to Supabase documentation, AI and vectors, and head on down to vector indexes, you can see here, these are the different operators and the classes that are associated with them. If you're curious to learn more information on IVF flat or HNSW, you can just click into these. We actually go into like how it all works under the hood. Moving on, let's get our RLS policies created, paste those guys in there. Let me explain them real quick one by one. First things first, you actually have to enable row level security. And you might be saying, hey, Greg, we never did that back on the other one. Well, turned out for storage buckets, RLS is actually already enabled by default under the hood when you first create your Postgres database. So you don't have to worry about that. In this case, since these are our own custom tables, we need to explicitly say alter table, enable row level security for both of those. That's an important piece. Next, we're going to do just basic row level security. So first of all, users can only insert documents for themselves, so they can't pretend to upload a document with somebody else as the user ID. They can only upload it for themselves. Same with querying their own documents. Same with inserting document sections. Actually, we'll talk about that in 1 second. The select on the documents, by the way, I should mention with RLS, a really good way to think of RLS is think of it as a filter. So what I mean by that is think about as if this statement here is actually just getting added as a where clause. So if I were to say select star from documents, if I were to run this as a specific user, then what it would do with RLS under the hood is that it'll actually automatically apply this filter kind of like a where clause so that this document's result only gets filtered to the documents that were created by that person. So that's actually what's going on under the hood with RLS. If there's no documents created by me, then this will come back with nothing, even though this table could have like millions of records. If none of those records belong to me, then it won't come back with anything. So that's really the beauty of RLS, right? As I said before, you could join this with other things, etc., and it still, at the end of the day, will always add this filter for you. Okay, down here we have some RLS for our document sections. So our second table here. Note though that our second table doesn't actually store the user ID in them at all. So how do we do RLS with our document sections? The answer to that is, well, we do store the created user in our documents. And since we have a foreign key relationship to our documents, we can basically determine who owns this document section through the document ID. And so the way we do that is using this query here. We basically say where the document ID is in, and then we select from the documents table where the created by user is the current user. And this will only return document IDs that are owned by the current user, and then therefore this ID has to match in that. So intrinsically, we're determining access through this other table. Same for updates and same for selects as well. Okay, so we're almost done our migration. Let's pause for a second and address another piece that will be necessary in order for us to actually set up some webhooks to actually invoke an edge function from within Postgres. If you recall, top of our migration, we have this extension called pgnet. And this pgnet extension allows us to execute HTTP requests from within Postgres. Essentially, this is webhook functionality. And I'll explain more about this in a second. But when we're developing locally, we're going to need to access our edge functions, which we'll explain again shortly. Edge functions we'll actually use to perform multiple things. We'll use edge functions to actually split up our documents into smaller sections. We'll also use edge functions to perform the actual embedding generation itself. If you're not familiar with edge functions are seen a lot these days on different platforms, right? Cloudflare, for example, has edge functions. They call these Cloudflare workers. Think of edge functions kind of as like AWS Lambdas. So when we're developing locally within Docker, we need to be able to access these edge functions through that Supabase gateway URL. So to do that, there's actually a really cool technique using something called Vault. So go ahead and copy this snippet here, and we're going to move on over to a file called seed.sql. So over here on the left-hand side, we have seed.sql. Paste that here. Essentially what this is doing is it's using this built-in feature called Vault. Vault in Supabase is a way to actually store configuration and secrets within the database itself. And the reason why you might want to use Vault here versus some other arbitrary table is because Vault actually encrypts your information. And when I say encrypt, I'm not talking about encrypting at rest. I'm talking about literally encrypting even within a live database. When you're using Supabase, the encryption keys are actually stored outside of Supabase, as you would hope for. You would never really want to store the key within the database itself. Otherwise, that's like leaving your keys within your front door and then walking away, hoping that no one breaks in. So in this specific case, we actually didn't really need the encryption part. We're just storing the Supabase URL, which isn't sensitive, but it's a convenient kind of configuration tool you can use for both configuration and actual secrets. Now, I should mention, if you're not using Docker and you're connecting to a database directly in the cloud, just replace this with the API URL from your own database on Supabase. From this API settings link here, you can grab the URL there and just paste that in there, and you can actually execute this directly within the SQL editor from Studio. So if you come down here and you can paste that in here, and that will go ahead and add that to your cloud instance. Coming back to our migration, we're going to copy this new function here. We'll paste it down here. This function is just called Supabase URL, and all it does is it grabs the decrypted value from our vault. I could probably do a whole nother video just on Vault itself. Feel free to, let me know if that's something you're interested in. Also, we do have documentation on this as well, of course, so feel free just to go there. Under Database, and then under Access and Security, we have Managing Secrets with Vault. And this goes into all the little details. Okay, last but not least, we're going to add one more snippet to our migration, which is a function. Copy and paste that here. And this function is called Handle Storage Update. And this is actually a special function for triggers. If you're not familiar with Postgres triggers. A Postgres trigger basically is exactly like it sounds like. When you perform an operation on a table, such as insert or update or whatever, you can actually trigger a function to run every single time. So in this case, what we're saying is anytime there's an insert on the storage.objects table, aka anytime anybody uploads a file, for each row, so for each file, execute the above procedure, handle storage update. So basically we can guarantee that for every single file that gets uploaded, it'll automatically perform this trigger function, which will follow the logic here. We're going to do two things. Number one, we're going to insert a document into the documents table that we just created. Again, this is a one-to-one relationship. We're going to store the name, which is the second path token, if you recall. And then number two, we're going to actually perform that HTTP request. So using that net extension, pgnet, we're going to call net.http post. It's going to perform a post request against our Supabase URL that we just configured earlier. And we're going to concatenate that with /function/v1/process. So this edge function doesn't exist quite yet, but we're going to create it shortly. Pass in the appropriate headers. We're basically forwarding through the authorization header through this, which means the user that actually triggered this function in the first place through the insert, their authorization credentials, so aka their JWT, will actually get forwarded all the way through here, all the way to the edge function, so that even our edge function itself can continue to inherit that same permissions from the user. I think that's pretty powerful, pretty huge, and also very important, right? That's something that, even once we get out of Postgres entirely into an edge function, it's quite important that we continue to inherit that user's permissions even from there, right? And then finally, we pass in the document body as JSON. In this case, we're just passing in the document ID. And specifically, what is this edge function going to do? Well, we're going to create one shortly here called process. And what it will do is, well, as the name suggests, it's going to process our document. So essentially, this is going to be the edge function that takes our document, the file that we uploaded, in this case, it's a markdown file, scans through it, splits it up into smaller chunks, and then actually inserts those chunks into those document sections, right? If you were interested in extending this application in the future to support, say, PDFs or some other file extension, this process edge function would be where you implement that logic. So that's great. For all intents and purposes, you can basically think of this trigger as a webhook. All right, let's go ahead and apply that migration. If you're running locally, you'll copy this command. If you're in the cloud, you'll run the next command. And just like that, our new documents migration has now been applied. If we go into Studio, we should expect to see our new documents and document sections table. Perfect. And actually, we even have our view there as well. Okay, this is a long one. Thanks for bearing with me. We're getting close to being done. The last piece of this step, of course, is to create that edge function that we just talked about. So to do that, we can create that by using this CLI command, npx supabase functions new, and then the name of the function. So we'll say npx supabase functions new process is going to be the name of our edge function. Coming over here, we'll see a brand new folder here called process. And then within that folder, we have a file called index.ts. The way edge functions work with Supabase is you'll have a folder for every single edge function that you have. And then the index.ts will be the actual implementation of that edge function, but you're free to add as many other files as you want in here that support this edge function if you want, and you can reference it from here. Also, if you had common logic that you wanted to share between multiple different edge functions, the pattern is you use an underscore. So if you have an underscore and then a folder name, anything within here, you can use them as library files or common files between the other ones. So I actually already pre-added this lib folder here for us with a handy util called markdown parser. This file has some utility functions that will help us parse our markdown function. Specifically, it's using the unified library to basically parse our markdown into an abstract syntax tree. I'm not going to go super deep into this, but think of it as basically for each type of element within a markdown file. So you got headings, you got regular content, like paragraph content, you've got code snippets, etc. When you split that into a markdown abstract syntax tree, it's basically just turns it into JSON with types. So basically, like, here's our heading, here's our content body, here's our snippet. And that's useful because now you can actually manipulate that however you like. So in our case, we have a nice handy function called process markdown. And what it will do is it will scan through the markdown, turn it into an abstract syntax tree, and then we can do some convenient things like split it by heading. So basically what this does is every single time it sees a brand new heading, so in Markdown you have the hashes H1, H2, or H3. Let me show you a quick example. So here we go, our Roman Empire file. If we look at the code behind this is just Markdown, right? So these are headings, right? This would be like an H1, this would be an H2, H3, because of the 3 hashes there. So basically what we're saying is every single time you come across a new heading, split that into its own new chunk. Why are we deciding to do that? Well, kind of like what we talked about earlier, we want to split by semantic meaning. And it just so happens the way Markdown files are written, or just documents in general, typically every time you have a brand new heading, that's kind of a new thought, a new section, new semantic meaning, right? In this case, this section is about the transition from the Republic to the Empire, etc., right? There will be one later on about geography and demography, right? So this is like a perfect split point, right? Because when the user asks a question about something, likely they're going to be talking about one of these specific topics, right? So we don't want to be having multiple of these together within one document section, and therefore embedding, we want to split them up logically. So it's worth noting this is not perfect. If I had like a heading, say H2, and then immediately an H3 underneath without text in between, I'd actually end up with just a blank section that would be kind of meaningless. So there's definitely more advanced things that we could be doing on top of this. I'll save that for another time where we could explore those options, but for now, I think this gets us pretty far. From there, we just do some extra logic to make sure that the chunk that it's split up isn't too long. Sometimes, even though it splits by headings, that heading and its content is actually still very, very large. And so it's too large still to fit within an embedding. So there's just some extra logic here to in a worst case scenario, split it by character. It's not ideal if it has to get to that point, but it's kind of like a worst case fallback. Coming back to our edge function, we'll go to our README once again. Right, also worth noting, since this is our first time working with edge functions on this workshop, there are a couple things you probably want to set up ahead of time. Number one, edge functions actually use Dino under the hood. Don't let Dino scare you. Dino is basically an alternative to Node.js. It's actually built by the same original author of Node.js. What Dino is basically fixes all the things that he regrets doing with Node.js. And one of the important things about Dino actually is that it follows the web standard like as closely as possible. So if you have ever used Dino before, you might have noticed that when you're importing things using Dino, quite often you're importing from like just straight up URLs, right? This is something you don't do in Node.js. You have to like npm install first. Dino, you actually just pull them directly from URLs, which sounds kind of crazy, but actually this is what the web standard does. If you use ES modules within the browser, which is possible nowadays, this is literally how you import modules within just vanilla browser spec. So props to Dino for committing to that. So real quick, how do URLs work with Dino? Well, there's these handy CDNs out there. In this case, we have a CDN called esm.sh. And what the CDN actually does is it just wraps npm modules. So all you have to do is say / followed by whatever npm module you would normally have to install. So in this case, Supabase / Supabase.js. This is literally just an npm module under the hood. But when you request that from esm.sh, it will automatically like go and fetch that npm module for you under the hood and then serve it to you over HTTP. And that essentially makes all these npm modules available through Dino. So we do the same with OpenAI and a bunch of other packages. Now we could have just put this URL directly down here into our import from here, but Dino actually supports this handy thing called import maps, which we're going to take advantage of in this workshop today. You can almost think of an import map kind of like a package JSON where you have your dependency list there. It's a little bit more specific to just our imports. And one reason why you might want to use an import map instead of just importing the URL directly is it's just a bit cleaner, right? This is now a little bit cleaner to import from. But more importantly, when we have multiple edge functions, it'd be good if we could commit to the same versions across the board. So if we create an import map, now all we need to do is import Supabase.js and we can guarantee that it will be using this exact version between all of our edge functions, right? So you're not forced to use these, but we'll be using this today. For development purposes, I would highly recommend you install Dino. This will allow us to get all the proper code hints. This is the brew command for those who are on Mac. If you're not on Mac, feel free to just check out Dino's installation documentation, and you can install through one of the many other package managers like Choco or through PowerShell or whatever you like. If you're on Linux, same thing. Go ahead and follow those instructions. And then one more thing I want to mention real quick. For those who are using VS Code, which I assume is many of you, there actually is in fact a Dino extension available. What I actually did with this repository is I actually added that as a suggested extension when you load this. So likely actually when you first cloned this repo and pulled it up in VS Code, you would have had like a little pop-up that said, hey, looks like there's some extensions that are suggested. Do you want to install install them. If you hit yes at that point, then that's perfect. You have everything you need. If you didn't hit yes and you regret it and now you want them, what you can actually do is just go ahead and hit Control or Command Shift P to open up your command palette and just type in recommended extensions, show recommended extensions, hit that. And then on the left-hand side here, it's actually just showing the exact same extensions here that were recommended. So for this repo, we recommended Dino. Of course, their extension will allow us to do all the proper code hints and IntelliSense within our index. And then Prettier for code formatting. ESLint is kind of like you pretty much always have this extension for linting. And then we use actually Tailwind for our Next.js front end here. So I do recommend that extension as well. You're not forced to, don't feel like you need to, but if you do choose any of these, I probably would at a minimum choose the Dino one, just because that will make your life way easier when you're actually doing any IntelliSense here. Otherwise, you'll probably get errors everywhere. Coming back to our README, let's go ahead and check out this import map. Everything should be here already, so we don't need to make any adjustments, but do note that that is there. Coming down next, we're going to go ahead and start working on our edge function. So what I'll suggest we do here is just let's copy the snippet, come back to our index.ts, select everything, delete it, and we'll just start from scratch with the snippet. First things first, we're going to need access to our Supabase client because recall, this is our process function. We're going to process our markdown and then we're going to have to store that data back into our document section table. And to do that, we're going to use the Supabase client, similar to what we're doing on the front end. Unlike the front end though, which got its URL and anonymous key from that handy env.local Next.js file, did a lot of that magic for us. With here, we have to actually grab those variables ourselves. Thankfully, it's not too hard. We just grab it from an environment variable called Supabase URL and Supabase anon key. That stands for the anonymous key. Note that these environment variables are automatically injected for you. So you don't have to worry about like creating an end file in this case to store these variables. The Supabase edge functions are actually smart enough to inject these automatically for you based on your project, right? So if you're working locally, like I am in this case, then when you spin it up in the Docker image, it will actually inject these for you. And then as soon as you deploy this to the cloud, then your cloud project will have its own unique URL and anonymous key, and it'll actually inject those for you there. So this is actually really, really nice in my opinion, because you can just write your code once and it will work in essentially every environment. Okay, first thing we do within this is check to make sure those variables exist. In reality, they're always going to exist because like I just said, they're injected in. But the thing is, TypeScript doesn't know that. According to TypeScript, it's a string or undefined just because TypeScript doesn't know that this environment variable exists. So I suppose we could have actually just added an exclamation at the end here to force it to be available. But the other option is just to do a check here. It's kind of like a type guard best practice to ensure that those variables are existed. I think I'm going to keep that in here just because it is best practice, and say you add more variables down the road that may not actually exist. I think it's a good habit to get into checking for these first. If they don't exist, then sending back a 500, right? So at this point, they're string or undefined, but afterwards, now that we have that type guard, we can have Supabase URL. And if I hover over that, you can see it's now no longer undefined. Perfect. Moving on. Step 4 here, you'll note that you might need to cache your dependencies. So coming back at the top here, the Supabase.js, for me, it just loaded in perfectly. For you, maybe there was a squiggly underline that said, hey, I haven't cached this file. If that's you, what you can do is actually just hit Command-Shift-P and type in cache. And there's a handy Dino function that will just cache all your dependencies. What that's really doing is it's just taking that dependency from that URL that we talked about and just caching it locally so that we can get like proper types and proper IntelliSense. I'll show you real quick. If I just change this to say 21.1, let's pretend that was a real version. Now I'm getting this underline. It's saying uncached or missing remote URL. So I can either hit Command or Control dot here to hit the cache button, or easier, you just hit Command Shift P or Control Shift P and then type in cache. And this will just cache all of them. But I'm going to change that back. Okay, let's keep going here. So let's copy this next snippet, paste it in, and I'll explain what's going on. So recall in our trigger function, we pass through our authorization headers, right? This is that JWT coming from our front end. And I told you guys that this is actually a really good practice to forward that to our edge function so that we can inherit those same permissions, right? This is that next step. We need to inherit those permissions. So first of all, let's grab the JWT from the authorization header, make sure it exists. If not, we'll throw another error. And then we'll go ahead and create our Supabase client. So to do that, we have create client, pass in our URL and anonymous key. And then using these global headers, we can actually inject in that same authorization header. This is how we can inherit those same permissions. And then we'll just actually add one more config parameter that says persist session false. This just tells the Supabase client that it doesn't need to worry about cookies or anything like that. We'll keep going on. Let's copy this next snippet. So next we're actually going to grab that document ID. Recall in our trigger function, we passed the document ID that was just inserted up into our process edge function as the request body. So we'll simply call the rec.json function to pull that out. And now we can go ahead and call supabase.from. Recall when you say .from, this is actually targeting a specific table or view. In this case, we're actually going to target the view because it's going to be convenient for us to have that storage path available as well. We're going to select, when you just say select with no arguments, that's equivalent to just saying select star. So this is equivalent to saying star like that. Next, we can add our filters. So you could say .filter, this is like a where clause, but there's some convenience filters like .eq, which means quality. So check to make sure ID is equal to this essentially. And then finally .single only returns one result. Otherwise it will come back as an array. But since we know that we're only trying to fetch a single document ID from our documents table, we know it's just going to be a single response. So we can go ahead and hit single. That way this is going to be a single value. Otherwise, if I took that out, we can see that turned into an array. Just like before, we're going to first check to make sure the document exists from the database. For some reason that didn't exist. That's a strange error, but we need to throw, we need to capture that situation. And also we're going to need to target this storage object path. So we'll also check to make sure that exists first. If neither of those exists, then we're going to return to 500. Next, let's actually download that file from Supabase storage. So we'll paste this next command. As you can see here, we're now using the storage subcommand, and we're saying from files bucket, and we're going to go ahead and download that storage object path. As you can see here, it's going to download it as a blob, which once again can be null. So we need to check that it's not null here first. And then afterwards, you can see it stripped away the null part because we've done that guard. Since this is a blob, we'll call the .text function on it, which basically is a promise that returns just the text contents of that file. Hence why we need to await here. And in the end, we're left with the string. So literally this file contents is going to map to the exact contents of our markdown file. Again, in the future, if you decide to extend this project and you decide to pull in, say, a PDF, then almost guaranteed you're not going to want to call .text here. You're going to need to find a way to turn this blob into something that you can parse as a PDF. I know there's lots of PDF parsing libraries out there, so you need to work with those libraries to understand how to parse that, for example. Okay, we're almost near the end here. This is a big one, I know, almost done. Let's copy this next snippet. Okay, finally we get to process our markdown. We already went over this process markdown function, so I'm not going to go into that again. We're going to just simply pass in the file contents, which again is just that raw markdown file. Here's the process version, which if you look into the type of this, process markdown is literally just going to return an array of these sections, where a section is going to contain our content, the heading, and potentially multiple parts if it had to split those chunks like we talked about earlier. From here, all we got to do is insert these into our document sections, right? So we can call supabase.from document sections. So this is going to target the document sections table. This time, instead of selecting, we're going to insert, and we're going to map through our document sections that we just split apart and pass in the appropriate columns into these document sections, right? So these here need to map exactly to the document sections column names that we created. So coming back up here, we have document sections. So we have a document ID and content in this case. Coming back here, document ID, content, these need to match exactly those columns. Now notice I'm passing an array, right? I'm mapping over these sections and then returning that array into this insert function. And that's intentional here, actually. Postgres and therefore Supabase supports batch inserts is what you would call this, where you can actually insert multiple records in a single transaction. This will return a possible error. If there was an error, we should check to see if that error exists. Probably console error it to the terminal so that if we're trying to debug this later on, we can view that error and use that to help debug. And then of course also just return a 500 to our front end. In this case, our front end is actually not a front end, it's just our trigger function, but this is still best practice. And then finally we'll log out what we just did, like how many sections we split it into and the file name, just for informational purposes. And then finally, last but not least, let's actually just return a 204, which is the status code you would send when you have no content. As you can see here, I'm just passing null to the body because we have nothing to return. And there's our edge function. We can go ahead and serve this function by running this next command, and this will serve it locally. So we'll run npx supabase functions serve, hit enter there. Fun fact, actually, edge functions will get served automatically for you as part of the Docker. When you say supabase start, it will actually serve these for you, but it's pretty handy to actually run this manually so that we can monitor the logs here. Of course, if you're using the cloud version, go ahead and deploy this now. Worth noting, by the way, if you are doing this locally like I'm doing right now, we do have a section at the end of this on how to deploy that to production. So basically, how to take everything you've done locally and then just push it to the cloud at the end. I assume most people actually want to go to production. That's the whole point of this video. So all that logic is in place. So don't worry, like if you haven't been following the cloud version along the way, all these steps will be available to you at the end of this README. Okay, and to finish up this step, we want to actually show these files that were uploaded back on the front end, right? It'd be great if back here on files, once you upload it, if we could actually see the file appear here. So let's go ahead and implement that logic real quick here. So going back to the front end app files page.tsx, we're gonna go ahead and copy and paste this into the top of the component. So once again, back here, app files page.tsx. We're gonna go to the top of our component. And actually what we're gonna do is we're gonna replace this here. This was just kind of a dummy placeholder for our documents. We'll replace that with the snippet. We're using a hook called useQuery, which comes from the React Query library. It's already pre-installed, so no need to install that now. It's already there. Go ahead and hit Command or Control-Shift-I to import that automatically. useQuery is just a really handy library to basically manage the lifecycle of your fetch requests. And it can do things like caching, invalidation, etc. So it is usually good practice to use a library like this. Plus the hook just makes it very convenient to use. In this case, we don't have to create like a use effect where we fetch things and create a state to manage it. We can just use a single hook to go ahead and fetch our documents and get them available here within the component. So what's happening here is we just give it a key. This is just a key React query uses for invalidation. Don't worry about it too much if you're not familiar. It just needs to be unique for this query. Next, we're actually going to call supabase.from. You've seen this a number of times by now, so you should be familiar. Documents with storage path. This is our special view that returns our documents table plus that extra storage path column. We call select with nothing, which just says select star, select everything. We have a data or error. If there is an error, we're going to raise a toast. In this case, it's going to be a destructive toast that will pop up that just says, hey, we failed to fetch the documents, and we'll throw an error. Otherwise, we'll go ahead and return that data. So let's save that, and let's go ahead and refresh our page. In this case, we have no documents. Actually, we did have a document, if you recall. We had a storage object that we uploaded, although I think we did a reset since then. So we're gonna have to just go ahead and upload the file again. In this case, it takes us directly to our chat interface. But let's go back to files and see if that appeared. Looks like it didn't. So what's going on? Okay guys, I realized I accidentally ran this migration before I had saved this file properly. So it actually ran the migration on like some of the schema, but not all of it. So now that I've saved it properly, we need to rerun this migration. Of course, you can't just say supabase migration up because it already thinks we're up to date. So we'll just have to do another supabase db reset in this situation. Hopefully, if you save this file properly before you ran the up, then you should be safe. Okay, because we just did a reset, we're gonna have to come back here, refresh. We're gonna be logged out, of course. So let's just create an account all over again. Not a big deal. Sign up, upload. Let's upload our file. Looks like our upload went successfully. So let's go back to our files and boom, there we go. We actually have a proper file coming back. So this is great. I think one last feature to just put the cherry on top of this is allowing users to click on this and download the file again if they wanted to. So let's go ahead and implement that real quick. To do that, we'll just go in the onClick handler for that guy and perform this logic to download it. So let's copy that, head on back to our page.tsx for our file. And then here where we have this to do to download the file, let's go ahead and implement that logic here. We'll paste it and then let me walk you through it. So number one, we're using supabase.storage from files, but note now we're calling this special command called create signed URL. Now, if you're not familiar with signed URLs, let me explain. What a signed URL essentially does is, well, by default, your storage bucket is private, right? We would have had to add extra logic to make that bucket public to the internet. So since it's private, the only way to actually access the files is, well, when you're authenticated. So in our case here, when we're using the Supabase client, we're authenticated. We've authenticated earlier when we logged in. But if I were to try to just navigate to this file directly, it wouldn't let me, right? Because it's restricted behind a private bucket. So instead, what we can do is we can call this handy create signed URL, which essentially creates a public URL. So as soon as you call this, it'll actually return a URL that's fully available to anybody in the world. But the idea is you create this URL for a very small period of time. So here, if you look at this, our second parameter is our expires in. This is in seconds. So what I've done here is basically said create a signed URL and it's going to expire in 60 seconds. So this link is only good for 1 minute. You can make this even shorter than that if you want, or you can make it longer depending on your needs. I think 60 works for our use case. Basically, the intent with this URL is that it's only ever going to be used by this client, this user, and also that they're going to use it right away. So assuming that's the case, you can keep this expires in very, very short. And you might be asking, hey, well, why can't I just use .download like we did before. Well, the problem with download is it's going to return a blob, right? And in the browser, it's not trivial to open a blob in a cross-platform way. If you've ever gone down that rabbit hole, trying to make this work in all the different browsers, it can be sometimes a little bit tricky. So in general, it's typically easier to actually just create a signed URL, and then you can simply call window.location.href equals that signed URL. So basically, it's as if you're just trying to redirect the page to that signed URL, but since it's just a file that we're going to download, it actually doesn't perform a redirect. It just downloads a file for us. And the browser is able to download that file because it's a public signed URL versus some special file behind a private bucket. When you just change the location like this, you can't pass in any authorization headers or anything, right? So that's why signed URLs work nicely here. Of course, if there was an error for whatever reason, we'll raise a toast just to let the user know that something went wrong. So if we save that and head on back here, we can test it out. Let's go and refresh the page, and then let's click this. And now we have the option to save it to our computer. All right, now that we have our processing logic in place, we can move on to probably the funner part of this workshop, and that is embeddings. So as always, I'm gonna go ahead and stash my old changes and check out step 3, just so we have a clean slate at this next step. Let's go ahead and get started. So one thing I really like about how we're doing embeddings in this workshop is the fact that we're actually using triggers, or you can think of them as webhooks, to actually generate the embeddings. And let me explain what I mean by that. So first things first, let's go ahead and create a new migration called embed. That will create a new file under Supabase migrations embed. Let's close our other tabs here. So we'll go ahead and copy this function first, and let me explain what's going on with this one. So similar to our documents migration, where we had a function at the bottom here called handle storage update. This was a trigger function. We're going to create another trigger function. This time we're going to call it embed. And essentially the purpose of this trigger function is to invoke another edge function that we're going to create shortly that's responsible for generating the embeddings. So you can kind of start to see the pattern that we're doing here, right? In a way, it's kind of reactive, right? After records are inserted into the table, like we did earlier, after documents are inserted into our storage table, then we have a trigger. You can kind of think about this as a webhook as well, that will automatically go ahead and create a document in the documents table and then invoke our process function, right? So in the same way, we'll have a embed function that will automatically get triggered anytime we, in this case, insert data into our document sections table, right? You might have noticed when we implemented our process logic, we actually never generated the embeddings, right? Down here, we just inserted the document ID and the content, but no embeddings. So where do those actually come in? Now is when that comes in. So the reason why I opted for this approach is because a couple of reasons. Number one is mainly just a separation of concerns, right? We have one edge function that's just responsible for splitting up that markdown, storing it back into the database. That's it, nothing else. And then number two, say we were to generate the embeddings right here in this function, that could add a bunch of extra latency and time that just adds another point of failure for something that's unrelated to really what this task is all about. So if you're able to, I would encourage you to try this technique of kind of splitting your big tasks into kind of separate modular edge functions. The one thing to note, though, of course, is there will be a certain window of time where there will be document sections that exist, but they don't have embeddings in place, right? Until this other embedding trigger has been executed, and then asynchronously those new embeddings will be created, right? But there will be a window of time where those embeddings will still be being populated. In our case, that's perfectly fine. Later on, we're going to implement a matching function, and if there's no embedding in there, then it just won't match. But if this was an important issue for your app, you could easily add in logic that would just check to make sure all those embeddings have been populated before performing matching, etc. So hopefully that made sense. If not, don't worry. I'm sure it'll become clear very quickly as we go through this. So first off, this embed function, we're going to put under the private schema once again, just because this isn't something we want to expose. It is returning a trigger, which means this is a trigger function. Now, as you get into the actual function body here, it looks a little bit complicated. And the reason for that is, it kind of is. The reason why it looks a little bit complicated here is just because it's doing some batching logic. Essentially, it allows you to batch insert your document sections. So recall back here, we talked about inserts. We're actually doing a batch insert. We're passing an array of sections in here, not just a single section. And so what that actually means is, say this insert had like 40 sections. So this markdown file was split into 40 different sections. By the time it calls this trigger function, it's going to have 40 records that it wants to generate embeddings on, right? So we need to ask ourselves, okay, are we going to call this embed function 40 times? Are we going to call it one time, passing all of our embeddings at once and this single function is responsible for creating 40 of them? Or is there somewhere in between where maybe we can batch them so that say we call this embed function 4 times, each doing 10 records to do a total of 40, right? So just to give you that flexibility and freedom to do the batching as you wish, I've designed this function with the batching in place, which does make it look a little bit more complicated, but hopefully that makes sense now that I've explained why that logic is there. Now, if you didn't want to do batching and you do indeed just want to do them one per embedding or one function that does them all, you can certainly do that. You just need to set your batch size accordingly. And we'll get into that next. So scroll down here, we're gonna go ahead and set up the trigger. So let's copy this. So we're going to call this trigger embed document sections. Hopefully that's pretty self-explanatory what it's doing. After insert on the document sections, again, that happens here. We're going to go ahead and execute the private embed function. Notice this time though, as opposed to last time when we set up the trigger, there were no arguments. This time we actually are adding 3 arguments. First argument is the name of the column that you want to pull the text content out of to generate that embedding. So in our case, for document sections specifically, we have a column called content. This is a one-to-one match to that column. This needs to be exactly the same as that name. Second argument is talking about the destination column. So recall in our documents sections, we have a embedding column, literally verbatim named embedding. So that is the name of the second column. That needs to match that column name exactly. And then the last argument here is our batch size, which is what we just talked about. So in this case, I'm going to set the batch size to 10, which means, again, if say we had 40 sections, it will actually call the edge function 4 times with a batch of 10 each. You can customize this as best fits your application. One more note real quick for those who are like to know the nitty-gritty details. Notice that for this trigger, we're saying for each statement. And that's actually different from the last trigger we did, which was for each row. So what's the difference between for each row and then for each statement? When we're saying for each statement, kind of as the name suggests, it's not actually on a per row basis. It's actually on a per batch basis in our situation, right? Coming back to our process here, we're inserting a batch of sections. So here, when we're saying for each statement, it's actually going to take all of those, again, let's say 40 sections, and execute this trigger function one time for that entire 40 batch. And this whole referencing new table as inserted, this is just the alias we're giving it so that within this function, we have like a temporary table to grab those new records from. Had we said for each row, then this would literally get called for every single document section one by one, and we just wouldn't have the opportunity to do this more advanced batching logic if you wanted to use that. Okay, next on the list. Everything I just explained, by the way, is all in this README. So pretty much nearly everything I've talked about should be explained in detail in this README. So feel free to come back to this on your own time and go through it if you ever need to kind of refresh. So that's actually it. We're done that migration. That was a pretty quick one, thankfully. So let's go ahead and spin up that migration. We'll save the file first this time. Run that. Yes, we have an issue where since I did the git checkout to a new checkpoint, they actually have different migration names. Forgot about that. That's easy though. We'll just do npx subase db reset. As always, if you're ever in doubt and you need a clean slate, this db reset command comes in really handy. Cool, so we have a clean slate. Come back here, refresh. So again, it's a new slate, so we'll log back in. Now, we're not going to test this yet because we're not done. Of course, we have this trigger function that's meant to call our embed edge function, but of course, we haven't created this edge function yet. So let's go ahead and do that now. So we'll copy this command. We'll call the edge function embed, just like before. That will create a folder under functions called embed with an index.ts. We'll copy this code, and again, just like last time, delete everything that's there and paste that in. So this is new stuff. Let me explain what's going on. First of all, this edge function is responsible for generating embeddings. How are we actually generating embeddings? Well, for those who are maybe familiar with OpenAI, they have an API to generate embeddings, right? So that is an option here. We could have called a third-party API. I mean, there's many of them out there nowadays. But it turns out that Supabase edge functions actually support generating embeddings directly within the edge function. So we're going to do that today. And what do I mean by directly in the edge function? I'm talking about literally the model itself is going to get loaded into this edge function, and we're actually going to perform inference directly in this edge function. If that sounds crazy to you, then I don't blame you. It's actually quite incredible that we can do this. Essentially, what we're going to be using is a package called Transformers, and Transformers is one of the most well-known Python ML packages that exist. but our good friend Joshua at Hugging Face has actually ported this over to JavaScript, and we can actually now run this within JavaScript. So here it is. Feel free to check out their docs. Under the hood, they're using a inference engine called the Onyx Runtime. If you do have any experience on the Python side, you might be familiar with something like PyTorch, or you might have heard of TensorFlow. Think of Onyx Runtime as another inference engine just like these ones are. The difference though is the Onyx Runtime can work in many different languages, many different platforms. That's one of their big things, is they focus on the cross-platform aspect. And once again, for those who like to go really under the hood and wonder like, how does this actually work? The Onyx Runtime for different platforms, of course, is doing different things. In the case of the web and Dino, it's using WebAssembly under the hood to actually perform that inference. So here, what we're doing is we're configuring Dino. We're just setting some options that are required for the Dino environment today. For example, we're not in a browser, so we don't want it to try to use a browser cache that doesn't exist, etc. Next step is actually to create the embedding function. So this right here isn't actually generating the embedding, but it's generating the embedding function. And if you're familiar with transformers, they have this concept of a pipeline. Think of it kind of like a function builder pattern where you call pipeline. First parameter is the type of inference you're doing. So in this case, for embeddings, we call this feature extraction. But there's many different types of inference out there beyond embeddings. And then the second parameter is the model that we're going to use. So today we're going to use that GTE small that we were looking at earlier, but you can of course replace this with whichever model you prefer. Do keep in mind though that the size of the model will affect how quickly it'll be able to load on the edge, right? So in general, if you're able to use smaller models, that's usually better for performance. And then also, in case it wasn't clear, these models are getting pulled directly from Hugging Face. Okay, moving on. We'll come down here and copy this next section. I'm not going to go over this again because I think this is pretty much identical to what we did on the last edge function where we have these environment variables that we're grabbing that have been injected in. We'll do the exact same thing with the authorization headers that we did last time so that we can once again inherit all the permissions and privileges that that user had that invoked this originally. Next, we actually need to fetch that text itself. So let's copy that. So what this is doing is this is kind of a dynamic function you can think of, right? So supabase.from, but instead of specifying a table, we're actually dynamically injecting that table from whatever the trigger passed to us, right? We're intentionally designing this edge function and trigger so that you can actually apply this to pretty much any table you want. You might have noticed in the way we design this, it's very general purpose. You can pass in whatever table and columns you want. And so naturally within our edge function, we want to continue with that. We want to be able to dynamically pass in which table this is coming from and the columns that they're coming from. Thankfully, with the Supabase CLI, this is dead simple. We just say from, pass in the table, select the ID. That is one requirement. The table will need an ID. And then the column, only fetch the rows for the IDs that were passed in, right? The current batch. And then also just make sure the embedding column is null, right? If that embedding column was already filled in for whatever reason, there's no point in generating that embedding again, right? Okay, now for the fun part, let's actually do the embedding generation. Paste this next snippet here. Let me walk through it. So we'll go row by row. Again, this is a batch, so we'll go through all the different rows that were part of this batch. In this case, it'd be like a batch of 10. So we'll grab the actual content. This is actually the string text content coming from that table. We're going to call generate embedding, which recall, this is that function that we built earlier from the pipeline. Passing in the first parameter is the text that we want to generate the embedding on. The second parameter is some options, and we need to do two things here. Number one, we need to set pooling to mean, and we need to set normalization to true. Now, this might be a repeat for those who have heard me talk about these options in the past, but I'll repeat it again. I'm sure many of you would like to hear about this. So first off, pooling, what does that mean, pooling? Well, to understand this, we need to get a little bit more low level here, right? When you generate embeddings and you're using an embedding model to generate sentence embeddings, which is what we're doing here, the model itself is not actually outputting one single embedding that represents that whole sentence or paragraph or whatever you passed in. What actually gets outputted by the model is a whole bunch of embeddings. And actually what it is a whole bunch of different embeddings, one for each token that you went in originally. So to get that final sentence embedding, you actually need to pool all those token embeddings together into one. And there's different methods to pool them, the most common being mean pooling, which is taking the average of them all. And that's what's supported with Transformers.js today. And for the GTE small model specifically, they use the mean pooling by default. So we'll continue using that here. So this is important, right? If you were to leave this out and generate the embedding, you'll notice that the output is actually not one single embedding, but like an array of a whole bunch of embeddings. And that's for each token. So don't forget this part. It's important. And then the second part is normalization, right? So without getting too deep into like linear algebra theory right now, if you think about your vector, it's got a direction and length in whatever n dimensional space it's in. And if you normalize that length, that is, if you take that length and turn it down into a length of 1, that turns it into a unit vector, and that's called normalization. Why is that important? Well, later on when we calculate similarity, so if you recall me mentioning we're going to use dot product, distance functions like dot product will actually only work when your vector is normalized. It has to be a unit vector. If it's not a unit vector and you try to use dot product, the outputs that you get will be just completely off and won't actually represent the proper similarity or distance that you expect. So if you're planning to use something like dot product, your embedding does need to be normalized. In general, I recommend normalizing it. Cosine distance, on the other hand, doesn't require normalization, but when your embeddings are normalized, cosine similarity and dot product will actually produce identical results. And the dot product algorithm is actually simpler, requires less math under the hood, so that actually translates to better performance. Okay, moving on. The output of this is actually a tensor under the hood. This is a wrapper around the Onyx runtime tensor. Again, we're getting a bit low level. To grab the actual embedding, in this case in JavaScript, this would be a number array. We just got to say array dot from the output data and store that into here. We're JSON stringifying it just because when we pass it up through our Supabase client, TypeScript expects it to be a string. So we'll just stringify it in this case to make TypeScript happy. Feel free to alter that. It's not a big hit on performance, but if you're worried about that, feel free to just do casting if you want. So of course, let me explain this real quick. We're gonna do a from that dynamic table again, and this time we're gonna call update. We're gonna update that embedding column with the embedding that we just generated. Of course, only apply that embedding to the current ID that we're iterating through right now, right? If we don't say this, this would update every single embedding in our table. That would be really bad. Don't forget your filters. Finally, we're gonna return our response just like last time. And again, it's a 204, no content. We're not passing anything in the result here just because we have no need for that. Now, if you are running on the cloud, go ahead and deploy this function now. If you're not, there'll be the opportunity to deploy this later on. So that's it. But before we move on to the next step, let's quickly test this out to make sure everything's working as we expect. So we'll do an npx supabase functions serve again. And this way we can monitor the logs for our edge function. This serve does serve all of the edge functions, by the way. So simply running this, we'll see logs for all of these. So at this point, we kind of have a sequence of events that we need to consider, right? Everything starts from just a simple upload to our storage table. That causes a trigger to create a document, as well as process that document, which in the edge function will generate document sections. And then we have a trigger on the document sections that will call the embed function, and then go ahead and asynchronously create embeddings on each of those document sections. So let's go ahead and upload a file and see if all those steps happen here. We'll pull up our studio here so that we can kind of monitor this in real time. We have no documents or sections right now, so that's perfect. Let's go ahead and upload our file. So we'll start with Roman Empire 1. Perfect, we'll come back here quick. Document, there's our Roman Empire. Sections, okay, our trigger has already ran. It's already parsed all these different sections out and put them into our document sections table, looking good. Notice our embedding vector column is null at first, right? Because these are done asynchronously through that last trigger. We'll refresh. Oh, we have some coming in. So for some reason, we're actually not getting, we got some embeddings generated down here, but only 3. Why is that? Well, here's our problem, guys. I accidentally put our return response within our loop. So basically after the first row, it just returned instead of continue with the rest. And the reason why we still got 3 is because recall we had batches, right? So we call this edge function 3 different times in this case. Whoops, let's put that out there. I'm gonna go ahead and do a full DB reset just so that we have a clean slate so I can really show you the expected output in the table. Okay, we're reset, refresh, create our account again. Come back here, we have a blank slate. Let's upload our Roman Empire 1. Come in here, there's Roman Empire 1. Already went ahead and created those document sections, looking good. Let's refresh. They're slowly trickling in here. And there we have it. We have an embedding generated on each and every document section. So to finish off this workshop, we're gonna just implement the last piece here, which is gonna be chat. As always, let's stash our old changes and then check out step 4. Once again, we will need to do a DB reset, I already know, because those migration names will be slightly different. Okay, and this last piece is gonna be mostly front-end focused. We're essentially gonna come into this chat interface and implement it. As you can see right now, hello, can't do anything, can't send it off. We haven't implemented any of this logic yet. Let's go ahead and do that. So first things first, I wanna point out that the way we're gonna implement our chat today is by actually generating embeddings on the front end within the browser. So first of all, why do we even need to generate embeddings again? Like, didn't we already just do all that? Well, we did that for our file contents, but there's actually one more place that we need to generate embeddings, and that is for our user message, right? Whatever you type in here, what kinds of food did they eat? This message itself, this query needs to actually be turned into an embedding. And as we talked about before, the reason for that is because this is how we're going to determine which pieces of our content, which document sections relate most to this, right? We need to have them both in the embedding space to determine how similar they are to each other. And those document sections will be the ones that we actually inject as context for our large language model, GPT 3.5. So the options are, we can either generate embedding directly in the browser, which again, I think is incredible that this is even possible. As I explained before, we'll be using Transformers.js, which uses the Onyx runtime under the hood, which uses WebAssembly to accomplish this. So that's why we're able to actually do that in the browser. I want to show you how to do this on the front end, just to switch it up and show you another option for generating embeddings. If you weren't interested in this approach and you would have preferred to actually generate the embedding for this message server side within the Edge function, you can certainly do that as well. But since I've already showcased that, I want to demonstrate how you do this on the front end. So of course, to do this on the front end, we need to install the Zenova Transformers package. Up until now, we've only been using that on the Edge function. So let's install that on the front end. And then we're actually going to also install Vericell's AI SDK. And this SDK is going to help us basically set up our chat interface very, very easily and seamlessly, along with the ability to stream the response back to the front end from OpenAI. Let's copy this, go ahead and install them. Next, we need to set up our Next.js config, specifically Webpack. We need this extra configuration just to tell Webpack how to deal with Transformers.js. We'll copy that. And this is going to live under next.config.js. And we can add that just as another key here under next config. So that's looking good. All right, next let's import some dependencies we'll use. This is going to be on the chat/page route. So we're moving on onto the chat page. Copy this. Once again, app, chat, page. We'll import these at the top and let's get started. So just like before, we're going to create a Supabase client at the top, copy that. Inside the top of our component, we'll paste that there. Recall that this is creating a singleton under the hood, so it's actually reusing the same Supabase client from the other page. Next, we're going to use a new hook called use pipeline. Let's copy that. So let's pause for a second and talk about use pipeline. So use pipeline is a hook that I actually built right into this repository. Fun fact, we're actually planning to make this available as its own NPM package soon, but for now, the implementation is actually just going to be directly within this workshop. Essentially what use pipeline does is it uses that same pipeline method that you saw on the Edge function, right? This should look very familiar. The first parameter is the task type, and then the second one is the model. So it's almost like calling pipeline. The difference is it does a lot of convenient things in React, such as number one, when you're performing inference within the browser, best practice would be to actually perform the inference in a web worker. So basically another thread. And the reason why is because inference can be potentially very computationally heavy. So if we were to perform that logic directly within the UI thread, then your web page itself will actually get blocked and potentially lag and slow down. So that's not good practice. We want to split that out into its own thread. And then number two, just dealing with asynchronous pipelines in React requires a little bit of extra work. Basically, you have to have either some state or a ref under the hood to keep track of your pipeline. And basically all that's handled for you within this hook. So under the hood, this thing will actually spin up a separate web worker thread to perform the logic. It does all the message passing back and forth between the thread for you. You don't really have to worry about a thing. Also manage the asynchronous pipeline for you. So basically this is just either going to be a pipe function or undefined. All you have to do is first check to make sure it's defined before you use it, and you're good to go. So that's what use pipeline is doing for you. And as always, this is outputting a function. We're going to call it generate embedding that we'll use later on to actually generate that embedding. Oh, and as noted here, it's very important that this embedding model here matches the one that you're using on the server side. If that wasn't already obvious, you can only be comparing embeddings that were generated within the same model, right? Also, you got to make sure that they're also either normalized or not normalized. More likely you've normalized them, but you need to be consistent on both sides. And you need to pool them the same way, of course, so the mean pooling. It's important that these are identical any place that you generate the embedding, whether it's front end, back end, or wherever, if you plan on comparing them to each other, right? If you're using different models, then the embeddings will be in completely separate embedding spaces, right? And they'll be meaningless to compare them with each other. Okay, next we're going to copy this snippet here for use chat. I'll explain this in a second. We'll replace our to-do here for the messages because use chat will actually wrap all of this for us now. So let's paste that. So let's talk about use chat real quick. Where does use chat come from? As you can can see up here, use chat's actually coming from that AI package. I told you this is a SDK created by Vericel. Vericel is the creator of Next.js. And essentially what use chat does is it's a very convenient wrapper around basically a typical chat setup that you'd be using with OpenAI or any other language model. So it does things like it handles your message state for you. Conveniently, it gives you like your input and your change handlers for your input. So you're still in control of like your interface and how you chat with it, which we'll implement that down below. But basically, they're managing all like that logic and state for you under the hood. And as we'll find out shortly, actually use chat manages streaming for us, which is actually quite nuanced and complicated if you try to do this manually. So this AI toolkit will really simplify that process. So not much to this. The one thing to note, of course, is the API URL. We need to set this to our edge function, which we'll create shortly after this. One last edge function called chat. And this edge function will be the function responsible for taking these messages from the client, forwarding them through to OpenAI's GPT, large language model, and then, of course, streaming that response back to the front end. You would never want to connect to OpenAI directly from the front end. First of all, CORS probably prevents that, which we'll go into CORS in a second here. And then second of all, you'd be leaking your OpenAI keys on your front end, which I have seen people do this already, and it's not a good time for them. So yeah, rule of thumb, never use secret private keys like OpenAI gives you on the front end. Never connect directly to OpenAI from the front end. You're going to want to go through your own trusted backend layer. In our case, edge functions are literally perfect for this. So unlike the Supabase client, which automatically infers this next public Supabase URL environment variable that we created at the very beginning for us, in this case, since this is a different SDK, we'll just need to manually pass that in there. Not too difficult. Just grab it from process.env and then tack on functions v1 and then the name of the edge function. We'll call this one chat, and we'll create that in just a little bit. Right, we have an isReady function as well. Let's copy this and just replace the one that's here. This is basically a Boolean that we'll use to know whether or not to enable or disable our send button. Basically, we only want to allow people to send the message once our generate embedding function has loaded. We'll go more into that in a second. Okay, in our input, we're gonna go ahead and set up these props. So we can copy this, go on down to our input, and I'm just gonna actually just replace the whole thing. That. Essentially what we've done is we added a value and an on change. Anytime a user types anything in here, it's going to call this handle input change, which Vericel handles for us through their AI SDK. And then, of course, since this is a controlled component, we need to pass the input that was just changed back to it so that the input's updated. Okay, now let's go into our submit handler. So when someone hits send, we want to basically handle that logic. So let's copy this, come into here. So we have our form on submit. This will get called anytime they hit that send button down here. So let's go ahead and paste that logic and we'll go through it. So first things first, let's make sure that generate embedding function has loaded. Basically under the hood, when you call pipeline from the front end, it actually has to go ahead and load that model from Hugging Face. And if this sounds really inefficient to you, it's actually not too bad, I would say, because yes, the first time it has to load that model, which could be big. Yet another reason why I was recommending that you prefer smaller models when possible. So that first time load is not too crazy. But the good news is Transformers.js will actually cache this in your browser. If you didn't know, there's actually a proper caching API available here under cache storage, Transformers. There we go, look at that. I've already loaded this once, so that's why this is here already. Actually, I can delete this cache entry so I can show you what it's like for the first time. But essentially you can see here it's actually caching the different files involved in that model. One of these is the model itself, and then some of these are just some configuration. So what this means essentially is once this is cached the first time, as soon as I refresh the page, the model loads instantly because it's pre-cached and available. Okay, once we check to make sure that's not undefined, now we can go ahead and call our function. Just like before, you pass the text input as the first parameter, and then the second parameter is our options. As we just talked about, we need to set these to the exact same thing we did on the server side. So this would be pooling mean and normalized true. Again, just like the server, will convert this into a number array and we'll send it off to our API. What's going on here? Well, since we're sending this to an edge function, we're going to create this in a second called chat. You need to be authenticated, of course, right, to connect to that edge function. So normally when you're using the Supabase client, you don't have to worry about this, right, because all that logic is handled for you within the Supabase client. However, since we're using, once again, this use chat and the AI SDK, we're going to have to actually just do a little bit of logic to pass in that authorization logic for us. So to do that, we can simply just call supabase.auth.getSession. That grabs the current session, which has an access token available. This is the JWT. And we can simply just pass that in as an authorization header to our submit route. Again, remember handle submit comes from this use chat, and we're good to go from there. Now under the hood, this handle submit actually will send those messages for you. So recall the use chat hook is keeping track of all of our messages for us, the inputs, etc. So when you call handle submit, actually by default, if I just got rid of all this, it would already be sending all those messages up to the server on our behalf. The reason why we need these extra things is for number one, what I just mentioned, the authorization piece, and number two, the SDK actually allows you to pass in extra information beyond those messages. In our case, we're going to actually pass in that embedding itself that we just generated because in this case, we decided to generate the embedding client side. If you didn't want that again, and you wanted to generate the embedding server side, you actually wouldn't need this at all. You could just send it up as is, and then you'd be responsible for generating that embedding using the latest message on the server side. But since we're going client side, we'll pass that in through the body prop. Okay, last but not least, we'll do that is ready disabled logic that I mentioned earlier. So we'll copy that, come down to our submit button, right? This is that send button. As you can see right now, it's disabled. Can't do anything because we said disabled is ready. Actually, I realize this is already in place, so you don't need to copy and paste this. But just to explain it real quick, recall this as ready becomes true when that model is available. So basically, keep that button disabled until that's loaded, and then it will enable the button for us. Let's refresh the page and see what happens. And there we go. Our send button went from disabled to enabled. So that was pretty quick, right? That's how long it takes to load when it's cached. If I were to delete this and then refresh, it'll take just a little bit longer. There we go, now it's loaded. So I'll let you decide whether or not this is something you think is worthwhile doing on the front end. Okay, next up we'll create our SQL migration. This will be our last SQL migration in this workshop. And the purpose of this SQL migration is to create, well, one last function. This is a Postgres function that we're gonna call match document sections. And this function is going to be responsible for actually doing that matching logic. Essentially, it's going to be doing that similarity search. So let's go ahead and create that new migration. Migration lives under Supabase, migrations, here it is. And we'll copy in this function. So let's go through this. Match document sections, what's going on? So this function takes two parameters. Number one, we're gonna call embedding. This is basically our query embedding, the embedding that we want to compare against our database to see what matches with it. So specifically in our context, whatever they type in here, hello world, this will be converted into an embedding, and that embedding will pass into this function as the first argument. Second argument is the match threshold. Basically the way pgvector works is, in addition to this new vector data type, pgvector introduces three new operators, and we briefly touched on this earlier, right? The operators look like this. This one specifically with the number sign hash is the inner product or dot product operator. There's also Euclidean distance, and there's also cosine distance. And so the beauty of pgvector, in my opinion, is it just turns all this new vector search, vector similarity logic into just plain old SQL at the end of the day. So if you're familiar with SQL, do whatever you would have normally done in SQL, just replace it with these new pgvector operators and you're good to go. So for example, let's think about this. We want to return document sections that match our embedding as similar as possible. That is, let's order our results by those that are most similar first, ranking down to those that are least similar. In SQL, this is just a simple order by clause, right? Order by document sections.embedding dot product are query embedding. And the result of this operation right here is going to be 1 being most similar and -1 being most dissimilar. And actually for inner product specifically, I should mention, because this will almost definitely trip you up. This is actually not inner product. This is actually negative inner product with pgvector. And the reason for that is because the way indexes work under the hood, they're a bit nuanced, and we need to be returning the results in ascending order. So assuming you want the results that are most similar, they actually needed to implement this as a negative inner product so that when you order them ascending, they come back in the order you expect, right? So actually this would return -1 if it was most similar and return 1 if it was most dissimilar, right? So ordering that by ascending will actually go -1 to +1, and we get them in the order we expect. Nothing crazy, just it is worth pointing that out so that doesn't trip you up later. Okay, great. So now we're ordering by those that are most similar using regular old SQL. That's amazing. But coming back to this match threshold, we're going to implement this as well, which is basically saying only include results that are within an expected match threshold. And without this, essentially what's happening is your returning everything. We're going to be returning every single possible document that this user has access to. Granted, in ascending order, so we're still getting the most similar ones first, but it's going to keep going all the way down till records that probably aren't very similar at all, right? And let's just say that perhaps only a couple were actually very similar, and the rest, starting at like the third record onwards, were like not similar at all. We probably don't even want to include that third result, right? But how do we know if it's going to be the third one that's suddenly not as similar, or the fifth or the 10th, right? So that's where this match threshold comes in, where we're basically saying, I expect the similarity to be at least, let's say, pretend this was 0.8. I expect the similarity to be at least 0.8 in order for it to be considered similar. Of course, you would just need to do a bit of trial and error and adjust this threshold according to your needs. For this project, we set it to 0.8. And if they're not within that threshold, then don't even return them at all, right? So let's say later on, we'll have a limit clause as well. We don't need to do that here. We can do that upstream. But let's say we limit by 10 records. What we're saying here with this match threshold is, sure, only limit by 10 records, but if everything past the first 5 are below 0.8, don't even return those. So we only come back with 5 records. And that's just to say, like, let's only make sure we're including results that actually truly are similar, and we don't accidentally inject context to GPT that is completely irrelevant, right? Hopefully that made sense. Last piece, of course, we're negating our match threshold once again, just because this is a negative inner product. And once again, I mentioned this earlier, but if you are using a embedding model that's not 384 dimensions, just make sure you do replace that with whatever the dimension size is. By the way, if you are curious to learn more about the negative inner product thing and cosine distance and how all that works here, I do have a little section within the workshop README here. Feel free to dig through that if you're interested. All right, and we'll spin up that migration. We are saved. Perfect. And if you're working off the cloud, go ahead and run the db push command. Okay, the final piece of the puzzle is going to build our chat edge function. Since we're going to use OpenAI as our large language model, you will need to generate an OpenAI API key. Feel free to follow the link in this README. This will take you directly to the OpenAI API keys page where you can generate one for this project. In general, when it comes to keys, really when you're using keys anywhere, I do recommend that you create one key per situation, per environment, per app, project, and a combination of those. So for example, I'll create a separate key for dev versus staging versus production. And the reason for that is if your key were to ever get leaked for whatever reason, the less places you're using it, the better, right? You don't want a key that you're using in both development and in production to get leaked, and then now it's not a simple key rotation for your local development machine. You have to actually replace the key in production. So make your life easier and create more keys than less. Once you have the key, you can copy and paste this command. This will create our .m file. Let's close some tabs here. Close. Let's go ahead and run that command. That will add a .m file to your Supabase functions directory. When this file exists in the functions folder, the edge function runtime will actually pull that in automatically. So take that key that you just created and just paste that here. Next up, we'll create a new edge function called chat. There's our new edge function. And as always, we'll just replace the contents. So this should look pretty standard at this point. The only difference now, of course, is we're creating a new OpenAI client, passing in that OpenAI API key from our environment, and then everything else is the same. So we'll copy our next snippet. This one is a bit new. This code here is actually needed for CORS purposes. If you haven't had the pleasure of dealing with CORS, CORS stands for Cross-Origin Resource Sharing. Basically, the gist is when you're building an app within the browser and you're making a fetch request from within your web page to another domain, that's actually not allowed by default for security reasons, right? Browsers don't want you to be able to just like arbitrarily fetch information from some other domain unless that domain explicitly allows it. How do you explicitly allow it? This is through these CORS headers. So what we're doing here is we're basically just saying allow star. So basically allow any domain to access this endpoint. Specifically, we have to say which headers we're allowing. And then down here, we need to handle the HTTP method called options, the options method, which is what CORS uses under the hood to determine if you're allowed to use that domain. All we have to do is handle the options method. If it is an options method, then just pass back these CORS headers and we're good to go. This is great for development. I would say though in production, probably it's a good practice to restrict these origins to the actual production domain that you're hosting your front end on. That's just a usual best practice rule of thumb. Okay, next up, we'll create our Supabase client. We've done all this already once before, so let's paste that in there. As always, pulling in the authorization header, inheriting those permissions, and creating our client. All right, now let's get into the meat of this. Let's copy this snippet. So let's go through this line by line. First off, await request.json. We've done this before. This is essentially taking the request body that was sent to this edge function. So in this case, it was a JSON containing these 4 things: the chat ID, message, messages, and since we have that extra prop that we added in, the embedding as well. Next up, we use our Supabase client to invoke our match document section function. Now, we haven't done this quite yet, right? Up until now, I've shown you like the .from, and we've used .storage, and we haven't used .rpc yet. So what is RPC? It stands for Remote Procedure Call. Essentially, RPC is just literally a way to execute Postgres functions. So since this match document sections function was created within Postgres, like we did back here, and also since it was created in the public schema, which is the default schema, that allows us to actually call RPC on it. The first parameter, of course, is the function itself, and then the second parameter is the arguments that you pass to that function. So embedding being the first argument, and then match threshold being that second argument. And as I noted earlier, we're using 0.8 for this project. One important thing to note about RPCs is the result of this RPC can basically behave like another table itself. In this case, take a note of the return type here, right? Right now, in this function, we say returns set of document sections. What does that mean? Well, that means the return type of this Postgres function actually will have the shape of a document sections. So essentially, for all intents and purposes, the result of this function is equivalent to querying the document sections table. That's the return data type. So what that means actually in this context is we can continue to chain multiple operations as if this was just a regular table that we were pulling from. So specifically here, we can say .select. So instead of saying select star or just empty, which means select star, we can say select content, which means actually only pull the content column from the document section. And then we can do things like limits. So we'll say limit 5 because let's say we had like 50 plus records that matched, that almost guaranteed won't fit within our prompt, right? Right now, we're just going to arbitrarily limit it to 5. Likely, you might want to consider making this a little bit more sophisticated. Maybe you pull a little bit more than you need, and then you can add extra logic down here that will trim it up. But for now, just to keep it simple, we're going to limit to 5 records. Of course, check to make sure that we actually got a match. And then next step is the prompt itself. Let's go ahead and copy the snippet and paste it in. Okay, first thing, let's look at our prompt. Since this is a chat-based interface, if you've never worked with OpenAI's chat completion models before, basically it's an array of messages that you have to form together. And for each message in that array, it's actually an object containing 2 things. Number 1 is the role. So is this the user talking or the assistant talking? You actually have full control over that message history and who's saying what when. And then you have content, which is the actual text content for that message. So let's quickly read through our prompt. You're an AI assistant who answers questions about documents. You're a chatbot, so keep your replies succinct. You're only allowed to use the documents below to answer the question. If the question isn't related to the documents, say, sorry, I couldn't find any information on that. If the information isn't available in the below documents, say, sorry, I couldn't find any information on that. Do not go off topic, followed by kind of like this heading, documents : and then the injected documents. Where does injected documents come from? Well, we build that up here ahead of time. Basically, we just make sure that there's actual documents that were returned from our match function. And if so, we'll go ahead and map through them, grab just the content, and then join them with 2 new lines. So basically, for every piece of content that it fetched, it's just going to concatenate them with 2 new lines between each one. Otherwise, it'll put in no documents found, and it will actually inject that down here so that the language model has that context. Oh, there was no documents found. It would basically encourage the large language model to basically reiterate that to the end user. So that's the first message in our list of messages. Everything after that is just ... messages. And this basically means inject the other messages that we've had. So AKA back here, if we had a conversation back and forth, multiple messages, all of those messages get injected in here. So basically what's happening kind of under the hood here is the very first time the user asks a question, they'll ask their question here. That will get sent up to the edge function as a single message. It'll basically inject in this first message, which is our prompt and our injected documents. Essentially, this is what's performing our retrieval augmented generation, or RAG. And then we just pass in that new message from the user. From here, we'll add some more code in a second, but OpenAI will essentially reply to that, send that message back to the front end, and we'll now have 2 messages here, right? Now, here's the important piece. The next message that the user sends will get sent to the backend along with the other messages, right? If this is your first time using large language models or OpenAI's chat completion model specifically, it's important to know that there's no memory going on there, right? Every new request to OpenAI's GPT models, you got to think of them like a clean slate. They have no memory of a previous conversation history. So actually essentially, in order to achieve this idea of a multi-message chat history, well, we just send the entire message history every single request. That's essentially it. There's no real other magic going on there. The same applies everywhere you see these chat models, right? Assuming you've used the actual ChatGPT interface, they're doing the exact same thing under the hood, right? Every single time you ask it a question, it's actually resending your entire message history along with it, or at least as many messages fit into the context window. Now, the only small caveat I should add to that is OpenAI did just release the Assistance API, which actually does have a true understanding of threads. So basically, from the API perspective, you don't have to send your message history every single time over and over again. But still under the hood, they would be sending that whole message history to the model. It's just a convenience thing. For today, we're not going to use the Assistance API, just so you can have full control over that message history, but you might consider using that in the future. So what we're doing is we're passing those same messages every single time, and then we're always injecting in this prompt every single time at the beginning. So next up, we're going to actually perform the completion itself. Oh, and fun fact, one thing I never really touched on was this code block. This is a template tag. Essentially what this does is if you put these template tags in front of a template literal, in JavaScript, a template literal is a multi-line string where you can actually inject variables. This code block specifically is a template tag that comes from the common tags library. Super handy, this library. And what it's doing here is it's basically stripping all these indentations, right? If I didn't have this here, then notice our indentation here, right? Since this is a multi-line string, actually everything over here is also getting included in that string by default, right? That's kind of what you'd expect on a multi-line string. So what that means though is when we send this to OpenAI, it's going to include all these extra tabs when really it shouldn't, right? So without that template tag function, we would pretty much have to do something like this in order to ensure there's no leading indentations everywhere. And personally, I just don't love that. It breaks our nice code formatting. So essentially, we can get away with doing it this way if we add the code block tag in front, which will strip away all these indents, including our injected variables. Okay, so the completion itself, recall we're using OpenAI's library here, comes from the OpenAI package. And again, just a quick reminder, we are in Edge functions. So the reason why we didn't have to put a URL here is because we have this import map in place, right? Remember this guy. OpenAI is mapping to this URL. So coming back down here, to perform the inference, we're going to call openai.chat.completions.create. We'll pass in the model. Our model today is going to be GPT 3.5 Turbo. You can change this to GPT-4 or whichever model you choose. Of course, GPT 3.5 is much cheaper than 4. So my general rule of thumb when I'm choosing the model is see if 3.5 gives you the results you need. And usually you can get quite a long ways with it. And then only once you need that really advanced reasoning or some more advanced situations would you maybe need to try GPT-4. But I would certainly try 3.5 first if you're able to. Of course, in the future, there'll likely be more models that will change this rule of thumb a little bit, but I assume this will still apply going forward as there's going to be some cheaper models versus more advanced models. Another thing to note real quick is today 3.5 is much, much faster than 4. So in a chat user experience like this, you would definitely want to err on the side of 3.5 if it can do the job, because otherwise your users are waiting quite a bit longer to get a response. Last piece here is a 0613. This is a model version. In general, in production, this is a good practice to tag this on here versus this would work too without it. But what this does is it locks it to this current version, right? It's important to remember that OpenAI is continually improving these models over time. And so they very well could actually release a new version of 3.5 Turbo, which they have. There was a version before 0613. They could continue to do that. And if you've designed your application around a certain model with certain expectations on what is returning, and then they change that behind the scenes, that could completely mess up or alter your application, right? So best practice as a general rule of thumb for software, but especially here for models, to lock in that version. Okay, messages. These are the completion messages that we just went over. Max tokens. This is talking about the max number of tokens that can be sent back. GPT 3.5 Turbo has a context window of 4,096 tokens. We've talked about tokens and how tokens differ from words or characters, so you should be familiar with that by now. But in terms of context window, let's talk about that real quick. So GPT 3.5 Turbo has a context window of 4,096 tokens. That context window limit includes both input tokens and generated output tokens. And that's important to know, right? So what I mean by that is, say between all these messages that I sent, all of them together added up to 4,095 tokens. That means I'm actually only leaving one token left for it to respond with, right? So that max token limit is shared between both input and output. So keep that in mind when you're considering how many tokens you want as your input. Specifically, this one here is actually talking about what are the max number of tokens I want it to respond with, right? So as opposed to that max context window I was just talking about, this max tokens is specifically referring to the generated response. Why would you want this? Well, tokens do cost. You are charged per token. So from that perspective, you might not want the model to give you this massive response back. Maybe you want to encourage it to keep it shorter. Maybe you want to leave enough room for your input tokens, so you don't want it to try to generate too many tokens as the output. In general, I would maybe start with something like 1024. And then if you're finding that it's continually getting cut off, you can increase that accordingly. Temperature, if you've never worked with these models before, temperature is talking about how deterministic the response is. What does that mean? Well, deterministic in this context means if I give it the exact same input, will I get the exact same output? And when you set the temperature to 0, that means it's fully deterministic, meaning if I send the exact same message every single time into the model, I'll get the exact same output every single time. Any temperature above 0, and I believe temperature can be between 0 and 1, I think. The way a lot of people like to think about it is a high temperature is like a more creative model and a low temperature is more deterministic. So any temperature above 0 will actually produce different responses given the exact same input. So in general, when you're using these models within your applications, unless you have a good need to increase the temperature, I generally stick to 0 as a default, just because as you're developing your prompt, as you're developing your application, you really do want that deterministic behavior, right? If you're experimenting with different prompts, trying to get the model to respond in a very specific way, and it's actually responding in 2 different results with the exact same input, you might go crazy. So in general, I would default this to 0. And then you can raise it if you have a need later on. Finally, we have this parameter called stream. Hopefully this one is pretty self-explanatory. If you've ever used ChatGPT, likely you would have noticed that the response from the assistant is coming back word by word versus like loading for a long time and then waiting for the entire response all at once. It streams the results back token by token, essentially. In our case, we're building a chat application, so that's a great option to enable. When would you want to use one over the other? Well, for a chat application, I would pretty much always turn it on because you want that snappy user experience, right? If you turn stream on, then as soon as it even has 1 token, it's going to start sending that back to the front end and your end user will get some feedback. Otherwise, if they have a big paragraph message, you might be waiting a long time, and to the user, it just feels like your backend is super slow. Of course, if you're building a different kind of application that's not chat-based and you require that entire response back before you can do anything with it, maybe you're getting OpenAI to produce some JSON or using the function call API. In those situations, you pretty much wouldn't be able to use streaming. Okay, finally, we just do 2 more things here. We actually wrap our completion stream coming from OpenAI in this OpenAI stream. Where does this come from? This actually comes from that AI SDK. So that same Vercel SDK that we were using on the front end, they actually have some back-end functionality as well that makes it really easy for us to stream that response back. So they support multiple different language models, OpenAI being one of them, so that's why we have to wrap it in this one. And then from here, we can actually send it in a streaming text response. This also comes from that AI SDK. So we pass that here. We do need to pass the chorus headers as well. Anywhere we do a response, we need to be passing those chorus headers through. And it's that simple. Kudos to Vercel for creating this AI package. These streaming wrappers actually make it really, really simple to deal with. If you've had the pleasure of trying to implement this without this library, there's actually quite a bit more work involved to deal with like server sent events and managing those. So this is quite nice. One last note real quick, if you are using the cloud, you will need to set that OpenAI API key as a secret. Recall, we just set that here in our .m file, but of course that would not work if you're working in the cloud. So you can set that using this command here. And then of course, deploy the function here. So that's it, we're done. Let's try it out. So let's go ahead and serve up our edge functions again so we can monitor the logs. npx supabase functions serve. Looks like we did a DB reset, so let's go ahead and upload some files. I'll close the Chrome DevTools. Looks like our embeddings are coming through. I'll actually go ahead and upload all 3 here. All right, and let's go ahead and chat. So some things we could ask it, for example, what was the most common food? Let's do that. The most common food in ancient Rome was cereals and legumes. Awesome. What's another one? What did people do for fun? Let's give that a shot. Hoop rolling, knucklebones, board games, cool beans. Let's do a follow-up question. I wonder if you can say, where is Circus Maximus? Rome, Italy. Okay. I guess that's expected. So there you go, guys. Chat GPT with your own files. Hopefully you learned something new today. Specifically, I hope you're able to learn that full end-to-end from scratch, building an application like this. If you want to go a bit further, feel free to move on to step 5. This is a bonus step. This is something I'll let you do on your own time. You might have noticed that up until now, we haven't had the best TypeScript types coming back from our database. That is, when we have a document or a document section, it'd be nice if the objects that came back from those queries actually literally had TypeScript types that matched their column structure and data types, right? You can actually do that with Supabase. You can run Supabase gen types TypeScript, and it will actually look at your database and scan the tables and basically generate TypeScript types for you based on those. So if you were to continue on, I would highly recommend doing that. Having those types are very useful and can basically help stop you from shooting yourself in the foot. Of course, after that, feel free to follow the going to prod production if you've been developing locally. All the steps you need to do that are here, including pushing your database migrations, setting up those secrets, deploying your edge functions. It's all here. And then finally, if you're interested in extending this application, we have some suggestions here of some additional things you can do that would be pretty neat. Feel free to try those out or just use your imagination. I'm actually really curious to see what you guys come up with. Thanks again, guys, and I'll catch you next time.